Esteemed guests, distinguished speakers, and experts from Indian automotive industry, ladies and gentlemen, a very good morning to all of you. I, Devyani, on behalf of International Center for Automotive Technology, welcome you all to this informative seminar on safety glass technology. I assure you all that today we will be gaining a lot of information on safety glass technology by the industry experts themselves. Now, I would like to welcome our dignitaries for the inaugural session. Please welcome today's chief guest, Shri Mahim Jain, along with panel members Shri Alok Jaitley, Shri Asif Mirza Beg, and Shri Kishore Kumar. I would also like to welcome Ms. Pamela Tikku, Senior General Manager and Chief Business Officer, ICAT. Before proceeding further, let's take blessings from God. So with folded hands and hearts full of belief, let's proceed for the lamp lighting.
शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्नमोऽस्तुते शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः.
Without further delay, may I now request Ms. Pamela Tikku to kindly deliver the welcome address.
Am I audible?
Yes, you're audible.
Okay.
Audible, ma'am.
Thank you so much. Good morning, distinguished guests. I would like to welcome on behalf of ICAT, although Director ICAT was supposed to address this inaugural session, but he was called for a meeting by ministry, so he could not join you today. And I'm here on his behalf welcoming you for this first event on safety glass. And this particular product is gaining a lot of importance in India, and a lot of things are happening. Having said so, I would like to welcome our chief guest, Shri Mahim Jain ji, Deputy Director General Certification, Bureau of Indian Standards. Guest of honor, Shri Alok Jaitley, Senior Vice President, Maruti Suzuki India Limited. Shri Mirza Asif Beg ji, Executive Director, Asahi India Glass. Shri Kishore Kumar ji, Head of Quality, same Gobain India Private Limited. I am also joined by Shri Amit Karwal for this inaugural session from ICAT. Distinguished delegates, colleagues from automotive industry, eminent speakers, fellow ICATians, ladies and gentlemen, a very good morning to all of you. It gives me immense pleasure to welcome you all for this first edition of International Symposium on Safety Glass Technology, ISSGT, being organized by ICAT. As you are aware that automotive industry is going through and has been going through for past 2 years through turbulent and tough times. And it was also compounded by the COVID-19 pandemic, which slowed down not only the economies globally, but also has impacted greatly the Indian economy. And automotive industry is not untouched by this degrowth. This outbreak has affected all industry, all sectors which impact the development of the economy, be it construction, industrial, manufacturing. And it also has adversely impacted glass industry, which not only has application in automotive industry, but also has large application in industrial and domestic applications in construction industry. To address these challenges, Government of India has taken various countermeasures to enhance the manufacturing capability of MSMEs, which include allotment of budget of 15,700 crores for financial year 2021 to help MSME industry grow more. This enhanced capital expenditure and infrastructure spending will have substantial and long-term positive spin-off for this sector. In order to motivate the domestic manufacturers of glass industry, Government of India has increased the import duty on safety glass from 10% to 15% in the recent budget. The Government of India wants local value addition. They want to promote local manufacturing under the mission of Atmanirbhar Bharat, which has been embarked by Government of India. Further, to ensure quality and reinforce the domestic manufacturers, government has issued various quality control orders for various products, and safety glass is one of those products. The Department of Promotion of Industry and Internal Trade, DPIIT, has introduced this quality order, as per which safety glasses for road transport, architectural usage, building and general usage will have to conform to a specified Indian standard and bear the standard mark under the license from Bureau of Indian Standards. Now, as per the orders, the notified items need to bear the IS mark for production, sale, trade and import in India. And this has also led to a new license regime in the country. I am pleased to announce that ICAT will play a very crucial role in this endeavor, which will help and enable local manufacturing and also getting products certified as per the quality control order. ICAT is fully equipped and with the state-of-the-art test facility to cater to the testing needs of safety glass, be it automotive or non-automotive. Not only for the prevailing regulatory test standard, but also as per customer-specific standards which are required during the development of a product. I'm glad to share that under the Atmanirbhar Bharat campaign of our Honorable Prime Minister, Department of Heavy Industry has assigned ICAT a task for creating a technology platform portal for facilitating automotive industry to become self-reliant by promoting innovation and adoption of global technologies. Under this program, ICAT has launched a technology portal called Aspire, Automotive Solutions Portal for Industry Research and Education. This portal will support industry and provide common platform for automotive industry, R&D institutes and academia to come together and to develop an ecosystem of innovation. The purpose of these technology platforms is to bring the industry problems on board and find those solutions to those problems either through projects sponsored by government or by industry, and also through grand challenges which are for key technology areas. Today we have virtually gathered for this first edition of International Symposium on Safety, Glass and Technology. We would have loved to have this session in person, but due to COVID pandemic, we are not able to meet in person. This platform is going to discuss with all stakeholders who are involved in the safety glass industry and deliberate on what are the requirements of quality control orders which have been stipulated under the orders, what are the future technologies, what are the innovations required, and what are the current and upcoming regulations for which the industry needs to be ready, and agencies like ICAT need to be ready to support testing, development, validation, and also certification. I would also like to thank our chief guest, Shri Jain, guest of honor for the inaugural session, and all speakers who have spared their valuable time to make this webinar meaningful and beneficial to one and all. I would like to wish this webinar a great success and hope all the participants shall be benefited by the experience and knowledge to be shared by eminent speakers during the technical session of this webinar. I would also like to thank all sponsors. Our sponsors are Era Global and Durataf, and also our media partners who have cooperated with us in conducting and organizing this webinar today. I would like to appreciate the effort of ICAT organizing team of this event under the leadership of Shri Amit Karwal, Mayank, Bansal, Vibhu, and our convention center team for putting this and organizing this webinar in the virtual platform in the present shape. I wish this webinar, a one-day session, a great success. And I hope that there are certain takeaways from this webinar which we can take forward and try to implement if there are certain action points arising out of this webinar. With this, I thank one and all for being with us today from wherever you are and making this event a success. Thank you so much.
Thank you so much for your motivational words, ma'am. Now, I would like to introduce our first guest of honor for the inaugural session, Shri Alok Jaitley. Shri Alok Jaitley is the Senior Vice President, Technical Administration in Maruti Suzuki India Limited and is associated with automotive field since more than 29 years. He did his BE from Delhi College of Engineering and MBA from the MDI Gurgaon. He joined Maruti Udyog Limited in 1991 as graduate engineer trainee and has grown in ranks and profile while working in different engineering domains. He is presently heading Technical Administration Division and responsible for vehicle homologation, representing MSIL in SIAM, OICA, and UNGRE Group. Prior to that, he headed body design in MSIL R&D for 6 years and was responsible for design and development of body, door, and lighting systems. He is also a governing board member of Society of Automotive Fitness and Environment, member of ARA Project Evaluation and Monitoring Committee. He is also on board of SAE Northern Section as Vice Chairman, Student Competitions. Epicycle and AVIM are two main competitions conducted annually in Northern region under his leadership. We welcome you, sir. May I now request Shri Alok Jaitley to address us on this occasion.
Thank you very much. I hope I am audible.
Yes, sir.
Thank you. Respected Shri Mahim Jain ji, Deputy Director General Certification BIS, Shrimati Pamela Tikku ji, Senior General Manager and CBO ICAT, other fellow panelists, Shri Mirza Asif Beg ji, Executive Director Asahi India, Glass Limited, Shri Kishore Kumar ji, Head of Quality, St. Gobain, India Private Limited, other distinguished attendees, delegates, my colleagues, and other fellow members from the auto safety glass industry, speakers, ladies and gentlemen, a very good morning to all of you. First of all, I like to thank you for taking out your valuable time from your busy schedules, and even in such a tough time of COVID pandemic, as we all know that auto industry per se suffered a lot because of the lockdown, and supplies and production all were brought to a halt in the month of April. Gradually, with efforts of everybody and support from government and administration, we are now in a state that we can touch upon a growth which is similar to 2018 or 19 time. And I thank our suppliers in the glass industry also taking up this challenge and making up the volumes up to a very, very respectable level. Also, I would like to thank ICAT for taking this unique initiative to organize this ISSGT. First time I think a glass conference is being held, and since I have been associated with the industry for so many years, I never got any chance to participate in a glass seminar like this, where I think lots of experts and people would be speaking about new technologies, the regulatory frameworks, the challenges, and the way forward. So to take my thoughts forward, I made a small PPT. If I can share my PPT, can somebody guide me how to project that? There are 2-3 slides I would like to push for putting out the points of QCO and their importance. So can somebody guide how to share the slides?
Yes, sir. Just
Is it visible?
yes, sir. We can see your slide.
Okay, thank you. Just a second. Yes, I hope it is clear now.
Yes, sir.
Okay, so going forward, how to go to the next slide? Okay, so I think uh, all people in the industry are well aware that glass is a very, very important part, and it is one of the integral part of the vehicle because it is not only meant for light transmissibility uh, and showing the transparency, like visibility to the occupant of the car. However, it is also one of a very important structural element. It gives structural strength to the vehicle as such. For example, in the front end collision, the windshield can provide up to 45% structural integrity to the cabin, and in a rollover also glass can this can go up to 60%. So automotive glass in all automobiles plays a multiple role. It protects occupants from outside environments, aids the driver and the occupant for visibility, and also affects a great amount in the vehicle styling. Uh, before we come to the topic of QCO, I think it is very, very important here to put upon a point that uh, what are the regulatory frameworks under which the auto industry globally operate? The safety glass, as we know, it's a very, very important safety item, and it is also regulated globally through various national and international standards. As in the picture, I tried to depict that throughout the globe, there are various standards and there are regulatory bodies which make it mandatory to test this component and also give mandatory markings. For example, if we go to the Europe, there is a UN regulation ECR 43. Then there is a GTR under UN 29 initiatives, GTR 6. Go to the US, then there is FMVSS 205 where the dot marking is there. And similarly in India, it's a IS 2553 with a BIS marking now made mandatory. So as a part of standardization and display of marking is also mandatory for all major economies. And I think in India also, these markings will also be now becoming mandatory. So we are in line with whatever our global partners or global regulatory framework is demanding. The standard marking also ensure the customers and authorities that a type approval component is being used, which is safe for the end user. Now, I just want to touch upon how the technology progression in glass is taking place and how the coming scenario of QCO will also augment quality in these processes. As we have seen that in the initial era, the glasses were normally low curvature, straight glasses, and mostly toughened type of glasses. And slowly we moved into various styling initiatives in the cars. The cars become more bold, stylish, and the visibility aspects also got improved a lot. The curved glasses came into picture. Safety aspects were added through laminated type of windshields and toughened glasses overall in the side windows. Uh, Further, there are other technologies which also not only give glass a feature of light transmissibility and visibility, but also other features which can keep cabin temperature low even when it is parked under direct sunlight conditions. Similarly, in our Baleno also we are using these UV cut glasses in order to reduce the heat load. Going forward, I think the usage of glass will further increase in order to give a very stylish look, as well as added features like panoramic sunroof. We will be seeing a lot in the vehicles in the domain to come. Head-up display will also be there on the these windshields, and the infotainment systems. Already there are big screens with the infotainment systems are also in many of the vehicles, and there is a dynamic VLT requirements also, which is pushing usage of glass to a large extent. Acoustic windshield and other plastic and glass glazing materials also in the anvil. I think as the technology will grow, the glass will certify its more dominant position in the vehicle with giving proper visibility as well as structural rigidity to the vehicles. So there is a long way to go, and we just not think that it's only the windscreen, the windshields, and the side glasses which only come into the domain of the glass industry. Now, coming to the topic of today's discussion, which is QCO, the Quality Control Order. I think all of us must be wondering why there was a need of a quality control order, though there are so many regulations. So if we look into the basic backgrounds, which I foresee that government around the globe are creating some kind of, I would say, some kind of environment or ecosystem through which the local industries can be protected and growth can happen. At the same time, it is also pushing for increase in the process quality, also creating more jobs and totally uplifting the economy. Obviously, with these initiatives, the quality of the parts and the process will improve. Also, it will also reduce our import dependability on such quality components. And I think in the long run, it will also support the Atmanirbhar Bharat initiative of Government of India. So there are various agencies and the government bodies who are taking steps and delivering notifications. Department of Promotion and Industries, Internal Trade under Ministry of Commerce and Industry and Ministry of Heavy Industry, and other industries are pushing these quality control orders and also making mandatory marking so that BIS standards can be certified across use of these products in India. And there are approved testing through BIS approved labs. How it is going to help us or impact the auto industry? Yes, certainly in the short term, we can see there is a direct impact on the suppliers because their processes are put for audit. There will be licensing requirement. There is a mandatory marking and control and inventory to be done to a large extent. There will be a little bit of impact on indirect, I would say, because import may also has to go through all this standard certifying processes. But I think once it is established, it will be very easy and quality will be overall ensured in this process. And this will come as applicable to parts throughout the value chain, be it a part which is being used in a OE fitment or in a spares also. More or less for aftermarket, the quality needs to be ensured because we know that aftermarket is little bit unorganized, and if proper safe products are not there, the overall safety of the end user may not be ensured. So, what are the different types of standards or the QCO processes? I think we will be discussing about it more in detail from the expert. But just to highlight here that the glass industry should not only see that these QCOs have come only for glasses. We have QCO for tires. We have QCO for wheel rims. Even for some draft QCOs are there for brake lining. So slowly the safety critical components which are ensuring the occupant safety as well as pedestrian safety, they will be coming into the ambit of QCOs, and the process quality needs to be ensured for all of them. So I think BIS is making a process which will ease this. However, there seems to be a little bit of hurdles. I think with the due course of time, they can be taken up. These processes primarily include plant audits, sample approvals, and markings. So, what are the challenges and the way forward? I will quickly conclude with these few thoughts from my side. As a OEM, we see that these QCOs have actually come with a very short lead times, and their introduction was also more or less very sudden. So I think proper lead time needs to be discussed with the stakeholders, and with proper deliberation, if we introduce, then implementation becomes easy. Another important point is that there is an inventory of old part per se, which have previous markings. So those needs also to be ensured that those inventories get properly exhausted before we jump onto the newer marking schemes. And I think one more important point is that end of production, wherever models have reached to the end of production, how to take care of those parts and how to ensure that they also get fully complied with the QCO. Now, if we dovetail, the component homologation and vehicle homologation finally need to be ensured with the new markings. So these are the challenges, I think, but they can be easily taken up. And few of the suggestions which I feel may be good enough to share in this forum, as the BIS already here. So I would like to take this opportunity and share few of the inputs from auto industry side. That what we have seen that in BIS approval system, there is an audit of the plant to be done. However, in pandemic, because of the travel restrictions, people, the regulatory authorities, people, test authorities, people not able to travel for foreign locations or in the domestic location as well. So if we can have some virtual audit kind of thing, then I think this can ease up the process. And also, if we can engage industry in finalizing some of the implementation lead times, then we can also very easily manage old part inventories and easy implementation of all the QCOs. I will also push here that if some exemptions can also be considered for end of production models, because since no new development is being taking place there, so they can be kept out of the regime of QCOs. And for my suppliers and partners, I would like to share that you need to work closely with the OEMs so that inventory of old part is properly consumed, or it is if it is not meeting the timeline, then you need to see how it can be utilized. So that we all can implement these QCOs with the proper process adherence and ensuring quality throughout in this value chain. This brings me to the end of my sharing, and I would like to once again thank ICAT team for arranging this special seminar. And I think throughout this seminar, I think we will be listening to various expert speakers with their valuable experience on the important topics like new quality order for glass safety in more details, what it has for all of us in these quality orders, maybe more on the material part and upcoming technologies, future technologies going to come. And with their immense knowledge, I think all of us will be greatly benefited. With this thought, I wish ICAT team all the best for this session, and I hope that all attendees will have a good interactive time also, and gain a lot on QCOs and per se on the glass processing. Thank you very much, and thank you for giving me this opportunity to share my views. Thank you a lot.
Thank you so much for your enlightening words, sir. Now, I would like to introduce our second guest of honor for the inaugural session, Shri Mirza Asif Beg. Shri Mirza Asif Beg has done his BE in Mechanical Engineering from Aligarh Muslim University and joined Asahi India Glass Limited in 1993 as GET. He is skilled in business planning, operations management, total quality management, strategic planning, and lean management. Currently, he is working as Executive Director in Supply Chain Management and Chief TQM. He has also headed quality assurance from 2002 to 2008 and was plant head for Chennai plant from 2008 to 2011. We welcome you, sir. May I now request Shri Mirza Asif Beg to address us on this occasion?
Thank you. Is my voice clear?
Yes, sir.
Shri Mahim Jain ji, Deputy Director General BIS, Shrimati Pamela Tikku ji, Senior General Manager and Chief Business Officer ICAT, other panelists, Shri Alok Jaitley ji, Senior Vice President Maruti Suzuki India Limited, Shri Kishore Kumar ji, Head of Quality Gobain, other distinguished guests, delegates, speakers, ladies and gentlemen. Very good morning to you all. It is my pleasure to be invited for this session, the first International Symposium on Safety Glass Technology, ISGT 2021. We are having this session virtually under this pandemic, for which we are impacted for almost a year now. And as we see, we are in some kind of a second wave in India, and the numbers are still rising. We know we have struggled a lot in this period, and especially in the manufacturing side, during the lockdown, there were many sufferings, not only related to the operations, but also to the workforce. And then when we started, we suffered a lot of shortages, not only for the manpower, but also for material. There was a severe supply chain issue, and those who are depending on the import supply chain suffered very severely because of the container crisis which happened, and it still is continuing. And especially for the glass industry, I mean, this growth is much faster than what was anticipated, and we actually, I mean, the kind of processes which supports manufacturing of automotive safety glass, the back-end processes are not easy to stop and start. The float glass manufacturing process, once is disrupted, it is very difficult to start. And many of the capacities globally have either in the period of shutdown or that period have stopped their production. And it is taking a lot of time for them to actually come on board. So with this much faster than anticipated growth, we are actually facing a lot of shortages for material, and we are also facing a lot of supply chain issues. The kind of commodity glasses, the supply chain needs to be very strong, and because of this global crisis of containers, etc., and we being largely supported by the import raw material, there are problems which we are facing. But in this difficult time also, we have many things to learn. I mean, this crisis was a great teacher for us. We could learn many things and adopt many new ways of working. We were just talking, Jaitley ji was talking about virtual audits, virtual meetings. Nobody have thought that more than 200 people can sit together in a virtual room and discuss like this. So these are very good new opportunities which this pandemic has thrown to us. So I was talking about specifically about the glass industry. The Indian glass industry has been reporting very good growth in this period after the shutdown when we started. Not only automotive, but non-automotive sector is also showing steady growth. And in the areas of the display glass, mainly related with the display of mobiles, tablets, laptops, where the consumption has increased many times than what it was before that. And in the auto sector also, we are almost at the same levels what we were before the pandemic. I mean, this has, as I said, has thrown a lot of challenges, and we are trying to cope with it. Still, we are grappling with the issues, and but at the same time, we are learning, and we are trying to see that these learnings translate into long-time improvement in our processes. It's a great opportunity not only to review our processes, but also to be leaner and to implement those things which will have long-term impact for the betterment of our company and for the industry in general. Coming to today's seminar, I mean, I think that a lot of effort and good work is being done by ICAT. And this activity of engaging all these stakeholders together from the safety glass industry, I mean, yes, it is a kind of first for me to be part of such an event, but it has a lot of value, and it will be a good opportunity for everyone to learn from each other. I would also like to take this opportunity to thank the event organizers and the team which was responsible for bringing this event together. And I think with the kind of lineup of discussion presentations we have, it will be a useful event. People will learn and take home the learnings from here. With these words, I would like to thank you once again and wish that this seminar is a success. Thank you very much. That's all for me.
Thank you so much, sir, for sharing your experiences with us. Now, I would like to introduce our third guest of honor for the inaugural session, Shri Kishore Kumar. Shri Kishore Kumar is a mechanical engineer with ME from REC Trichy and BTech from SP University, Tirupati. He started his career with Lucas TVS and was with Value Clutch India division before moving to Saint Gobain Securet in 2007. He has a professional experience of over 28 years in the field of auto electrical, lighting systems, clutch system, and safety glazing. He handled various roles in the field of R&D process and equipment planning, lean in manufacturing system, new project management, and from 2016 onwards, he is heading quality functions as well. Functioning from Chennai, he is a part of Securet India leadership team, driving customer satisfaction with focus on continuous improvement in customer service. We welcome you, sir. May I now request Shri Kishore Kumar to address us on this occasion.
Good morning. Thank you. Am I audible?
Yes, sir.
Okay. Shri Mahim Jain ji, DDG certification BIS, Srimati Pamela Tikku, Senior General Manager and CBO ICAT, and panel members Shri Alok Jaitley ji and Shri Mirza Asif Beg ji, and really I want to really first thank ICAT to really giving this particular privilege of really having the inaugural function for this particular virtual international symposium on safety glass. Okay, I thank ICAT to really organizing this virtual symposium. Okay, I think the team has left very short things to me. Both Ashok Jaitley ji as well as Mirza Asif Beg ji both have really snatched away the key points what are there on the topic. Okay, but let me put forward some key things to be really looked at.
Sir, sorry to disturb. Sir, sorry to disturb. Can you please switch on your camera? We have already shared a request with you. Yeah, sure.
I think there's some problem with the network, so that's the reason I just switched off the video. Okay. I take this opportunity to really capture back, okay, right, the Indian automotive industry. I think Ashok Jaitley has, Alok Jaitley has really shown a simple way of representing in a pictorial way right from ambassador today where we are at. Okay, to really go through this particular automotive glazings, I think we should really thank the government as well as BIS to put the standard in place right from day one. Okay, really, this IS 2553 has played a very, very critical role to ensure that the safety is being taken care on the product level as well as the vehicle level. Clearly, the IS 2553 Part 2 has taken leaps and bounds of upgradations, and currently it landed as a quality control order. And to really put forward, I think way back in 2009 also, the ISI mark on glazings was become mandatory for domestic suppliers, and we have introduced that one long time back. Oh, coming back to the QCO and its impact. Really, QCO is already put in place for all domestic suppliers, okay, and we are already abiding by that. And what really matters is the overseas manufacturers today unable to really catch up with the BIS licensing. Okay, that is an impact where the OEMs will really have this particular impact on their car productions or vehicle productions. Clearly, we request BIS to really take care of this particular thing, and there were a lot of meetings happened with DPIIT as well as BIS also participated in all this meeting, where there's a conscious decision to shift this particular QCO by 1 year. But nevertheless, we have this challenge of COVID. I'm sure that BIS will really look into the possibilities of conducting virtual audits of the plants, let it be a domestic plant or an overseas plant, to really ensure that this QCO implementation happens smoothly during the 2022, when our by April 1st. So I request BIS to really take this point and really actively look at starting doing the audits by virtual mode. And to come back to the technology, really with the automotive glazings, okay, it is not just glazing. There's a lot of things beyond the glazing, because there's a lot of things which could be displayed on glasses. There are a lot of things glass can communicate. So glass is a dielectric material, okay, where now you can communicate a lot and you could do a lot of wonders with glass. So of course, with the emerging technology of EVs coming in place, glass plays a very, very critical role in really shaping the industry. And I'm sure there's a lot of technology which is available still to really reap the benefits of value additions of the glass, to give better safety for the end users, and to really add value back to the OEMs, and to serve the society in a better way. Okay, I really appreciate ICF, ICAT to really organize this sort of a international symposium on safety glazing for automotive requirements, because this is a very specialized and niche subject which is not that easy to really people to understand. And there's a very good opportunity for all the members who joined here to really take the advantage of this particular symposium to understand and really pose the questions whatever you feel like. And I really thank ICAT for organizing this and wish all the best for this particular seminar. Thank you.
Thank you so much for your inspirational words, sir. Now, I would like to introduce today's chief guest, Shri Mahim Jain. Shri Mahim Jain is an electrical engineer who joined Bureau of Indian Standards about 35 years ago, and prior joining BIS, he worked in PSUs and various companies in private sector. In Bureau of Indian Standards, he has worked in different capacities at different locations. To name a few, he has worked at Jaipur BIS branch to look after the state of Rajasthan, at Parwanu branch to look after the state of Himachal Pradesh, and currently he is sitting at Delhi. He has also worked as Deputy Director General, which caters to the state of Maharashtra, Gujarat, Goa, and Union Territories of Dadar and Nagar Haveli and Daman and Diu. He is a lead auditor of various management systems and has traveled extensively in India and abroad. He has contributed significantly in various activities of BIS, namely standards formulation, laboratory testing, and conformity assessment. He presently holds the post of DDG certification at BIS headquarters, New Delhi, and deals with the policy related to various conformity assessment schemes of BIS. We are indeed honored by your presence, sir. May I now request our chief guest, Shri Mahim Jain, to address us on this esteemed occasion and share his industry perspective of safety glass industry.
Thank you very much. Shrimati Pamela Tikku, Senior General Manager and CDO ICAT. Our panelists for this inaugural session, Shri Alok Jaitley, Senior Vice President, Maruti Suzuki India Limited. Shri Mirza Asif Beg, Executive Director, Asahi India Glass Limited. Shri Kishore Kumar, Head of Quality, Sales Gobain India Private Limited. Distinguished guests, colleagues from automotive industry, various other speakers who will be joining in the other technical session. Ladies and gentlemen, a really very good morning to all of you. It is certainly a privilege for me to be invited to this ever first edition of the International Symposium on Glass Safety, Glass Technology, ISSGT 2021. This edition of Symposium is being organized virtually this time, as all the distinguished speakers have already said. This is certainly a time when it is very difficult to actually meet physically, but then it is also a pleasure to see at least virtually all of us who are there in the trade. This is really a good opportunity. So, as we all know, that previous year was certainly not good either for the well-being of the humankind as a whole, or if we talk about the automotive industry or non-automotive industry, or otherwise, or particularly for the glass industry. However, we've learned from this a lot of experience we have now, and we have learned how to move ahead in this tested times. So I think still we are going ahead in this period of COVID also. As far as the glass making is concerned, what I feel is this is a very ancient art which dates back to 3600 BC. And in India also, it is believed to be existing since 1700 BC. So we all know that Glass City of India, the Firozabad we have, which started production in the year 17th century. So the modern Indian glass industry is around 100 years old. The first glass plant was set up in August 1908 by Lokmanya Gangadhar Tilak at Telangana, Maharashtra. This is certainly something related to the glass industry we have, and in our India what we have at the moment. The industry has made certainly steady progress since India's independence. The India's safety industry had a long journey since then, which includes a lot of innovation, development, and advancement. As per the report we have with us, the global flat glass market is expected to grow up to $170 billion by 2025 at a CAGR of 7.06%. Global emphasis on energy efficiency is driving the demand for flat glass for architectural, construction, automotive, and solar energy purposes. On the other hand, energy-intensive manufacturing process and implementation of stringent emission norms are expected to pose a major challenge to the global flat glass industry. As far as BIS is concerned, it was established in the year 1947 and has been operating its product certification scheme since 1955. Over these years, the popularity of the scheme and the ISI mark has grown. As presently, there are 37,000 licenses within the country, and there are about 1,100 licenses which have been granted outside the country under the Foreign Manufacturer Certification Scheme. The product certification scheme which BIS runs is based on the international practices of ISO IEC 17067. BIS has been operating this scheme for multiple products, some of which are under voluntary certification and some are under compulsory certification. So the products which are under compulsory certification, they all we know under compulsory certification or mandatory certification regime by the government, taking into consideration the concerns like public interest, protection of human, plant, and animal health, the national security, and certainly the unfair trade practices which are there in the trade. In September 2020, the Quality Control Order on Safety Glass was issued by the Ministry of Commerce and Industry, DPIIT, Government of India, to regulate the quality of various types of safety glasses being imported or manufactured in India. BIS is the certifying body for issuing this BIS certification for India, and overseas clients look forward to work in coordination with the reputed authorized testing agencies like this. Presently, two Indian standards, namely safety glass for architectural building and general uses as per IS 2553 Part 1, and safety glass for road transport as per 255 Part are under mandatory certification. The current standard date, as already has been told, is 1st of April 2022. This means that from 1st of April 2022, no person shall manufacture, import, distribute, sell, hire, lease, store, or exhibit. This is as per the regulation we have for BIS. Exhibit for sale or safety glasses as per this, except without a valid license from the Bureau. So through this platform, I would request all the concerned stakeholders to take note of the implementation date, which has already been extended up to now, 1st of April 2020. And all the manufacturers with a safety glass may kindly obtain the license timely so that the supply chain doesn't get adversely affected. As far as the status of the licenses as on date is concerned, there are about 41 licenses which have been already granted for Part 1, and there are 35 licenses against IS Part 2 in India. Just for the interest, the first license was granted by India in the year 1988 to Messrs. Chandra Lakshmi Safety Glass Limited in Sonipat, Haryana. This license is still operated with us. As far as the applications are concerned, we have got applications in India and 2 applications for Part 2. 30 applications are for Part 1 and 2 applications are for Part 2. And for the foreign manufacturers also, we have got quite a number of applications. There are 3 licenses which have been granted, and there are about 70 plus applications which are pending. So as we were talking about the virtual inspection, yes, certainly because of the pandemic situation, we have not been able to go outside the country or carry out this visit. So the issue of carrying out the virtual inspection has already been taken up with the concerned ministry by us. And it is there under active consideration as to how to handle not only the foreign manufacturers from outside from within the country for this particular product, or the manufacturers who are outside the country for the glass, safety glass, as well as for the other products also. So there are some issues with regard to the regulation provision there, but we have already initiated this process and we are trying to make enabling provision for the virtual inspection also. Earlier, this provision was not there in the regulation of BIS. So the proposal has already been sent by us, ministry, and let us hope that if as soon as this facility is made available through the regulation to us, we'll be making use of it, because certainly it is affecting the manufacturers who are not in the country. Because in the country today we are able to carry out inspections. Still, it is possible for us to move within the country and carry out inspections. But when we talk about the who are outside, the travel advisories have been issued by the Government of India also, and there are restrictions in the country where the manufacturers are located. So there can be situation when we go and then we have to be quarantined for some time there. And then when we come back also, then there could be something. So we are looking into the virtual inspection also, and then there could be the possibility of appointment of agents outside also. But then it all takes, we have to follow certain procedures we have. So that will appointment of agents to carry out inspection on behalf of BIS outside the country is a possibility, but then it will certainly take time to appoint those agents or to carry out the inspection. So that is also being considered by the government, and then virtual inspection possibility is also there. But then it could be, if the virtual inspection is carried out, so subsequently there could be physical inspection also when the situation normalizes. So that all thing is into active consideration by BIS. So coming back to the scenario with regard to the lab, certainly as far as the safety glass industry is concerned, we have got ARI laboratory is there with us in Pune, and the ICAT lab. These are the two prime labs today which are NABL accredited and BIS recognized labs. So most of the samples are going to these labs only, and they have very, very good contribution as far as the implementation of the QCO with regard to safety glass is concerned. I am really thankful to these labs, and particularly the ICAT, for organizing this seminar to make people aware of the technological advancement which are taking place, and also the regulatory framework which is there, and very, very important and essential for all of us to comply with. So as regards the symposium, today's symposium, the work and efforts made by ICAT team is really worth appreciation, and it is going to provide a platform to share knowledge. And today we are going to have a lot of discussions also of the future technology. Some of the distinguished panelists in the inaugural session also have talked about the technology which is going into, and also the constraints. So I can take this opportunity to thank our Indian and foreign delegates who are associated with. I could see that there are about 175 or so participants who are there at the moment with us. So certainly it is going to give them a lot of information with regard to the safety glass. The speakers have passed on in the initial session only. Our three, Mirza ji, Alok ji, and Amit ji, they have already touched upon the issues and talked about the requirements which BIS has to do, what the central government has to look into. So that we are also we are into it, and we are also seeing it. So they have already passed on the best knowledge about the technology and the regulatory compliance process. I'm sure that the audience would be benefited with this. A lot of in the further technical session also there will be good many takeaways for the audience. So with these words, let me once again thank the management of ICAT for inviting me as the chief guest and giving me an opportunity to have deeper look into the glass industry problems, the status with regard to the technology and the challenges we have. We have to jointly come, and I would request any of you as an association, otherwise you can always come to BIS. We can have one-to-one interaction also. We can have VCs also with the manufacturers and look into the problems and put forth jointly to DPIIT, who's the regulatory body, that what are the issues and how can they be resolved. With regard to the implementation part or the operation part, if it is something some manufacturers are facing some difficulty, yes, this BIS is open anytime, anybody can come. Individually also, as an association also. In association, it becomes easier to represent issues of various manufacturers, whether within India or outside India. That is one issue. So I once again thank and wish all the best to this first International Symposium on Safety Glass Technology. Thank you very much to one and all. Thank you.
Thank you.
Thank you so much, sir, for sharing such in-depth knowledge with us. Now, I would request Shri Amit Karwal, AGM in HVU ICAT, to deliver the vote of thanks.
Thank you, Devyani. Am I audible?
Yes, sir.
Chief guest for inaugural ceremony of this symposium, Shri Mahim Jain ji, DDG certification BIS. Our guest of honors, Shri Alok Jaitley ji, Senior Vice President, Maruti Suzuki India Limited. Shrimati Pamela Tikku ji, Senior General Manager and CBO ICAT. Shri Mirza Asif Beg, Executive Director, Asahi India Glass Limited. Shri Kishore Kumar ji, Head of Quality, Saint Gobain India Private Limited. Distinguished speakers, delegates, and colleagues from Indian automotive industries, media, ladies and gentlemen, a very good morning to all of you. It's my proud privilege to propose vote of thanks on this occasion of inaugural ceremony of this symposium. I, on behalf of ICAT, extend heartfelt gratitude to all the speakers who would be sharing their rich experience and views during this webinars on safety glass technology. By conceptualizing ISS GT 21, ICAT have set foot forward creating a platform which would not only bring all the stakeholders together, but will also benefit safety glass industry to understand more about upcoming quality control orders, futuristic technology in the domain of safety glasses and regulations. I would like to thank all the eminent speakers for this webinar. Speakers from Bureau of Indian Standards, BIS, Asahi India Glass Limited, Saint Gobain, and IIT BHU, who have joined this webinar today to share their knowledge and rich experiences with us. On behalf of ICAT, I would like to thank our sponsors, Messrs. Era Global Standard Certification, Messrs. Duratuf Glass India Private Limited, and media partners for supporting this one-day virtual event. Without their support, this event could not have been organized. Thanks to all sponsors and our media partners. I hope they will keep supporting us for our future events pertaining to various domains of automotive technology. An event like this cannot happen overnight. The wheels started rolling months ago. Our ICAT management has directed us and guided for conceptualizing such event for supporting automotive industry, particularly safety glass industry, because I think it was the vision of our management to have such common platform for glass industry also, because they are also part of this automotive industry. It requires planning and bird's eye view for details and execution of such webinars by coordinating with the our guests and then delegates, speakers, participants. We have been fortunate enough to be backed by a team of very motivated young and dedicated colleagues of ICAT who have worked tirelessly behind the curtains to make this event as a reality. I would like to extend my heartfelt thanks to the senior management of ICAT and my colleagues for their support and guidance for organizing this event. So thank you very much and have a nice day. Thank you all.
Thank you so much.
Thank you so much for your encouraging words, sir. We will now have a 15 minutes break, after which we will have our first technical session of the day with the topic of upcoming quality controlled orders, and the speakers will be esteemed scientists from Bureau of Indian Standards.
Thank you, Devyani. Thank you, everybody.
Thank you so much.
Thank you.
International Center for Automotive Technology, ICAT. The most populous democracy in the world, the Republic of India is a vast South Asian country with diverse terrain ranging from the Himalayan peaks to Indian Ocean coastline and a history dating back 5 millennia. A cultural melting pot, it is a pluralistic, multilingual and multi-ethnic society which became one of the fastest growing major economies post market-based economic reforms in 1991. A key contributor to this enviable position is the automotive industry, which accounts for 7.1% of the country's gross domestic product, GDP. Located at the northern hub of automotive industry in Manesar, Haryana, ICAT has emerged as a comprehensive technical partner to the automotive industry and renders valuable services such as homologation and certification, developmental projects and testing and automotive R&D projects. The state-of-the-art infrastructure at ICAT is pivotal in carrying out these functions and can be broadly classified into following areas of excellence. Powertrain Laboratory. Powertrain Lab offers services in the fields of vehicle and engine emission and performance test along with calibration services. The labs are fully equipped to undertake the homologation test of both the engine and the vehicle as per latest Indian, European and other international regulations of automobiles. Apart from homologation, performance measurement of engine and vehicle, fuel consumption measurement and optimization, emission tests and optimization including EGR, engine mapping, exhaust temperature optimization and ECU calibration of vehicles. Engine Test Cell, ETC. There are 13 transient test cells ranging from 35 kilowatt to 880 kilowatt capacity. These engine test cells are capable of carrying out advanced tests such as performance, optimization, emissions measurements, EGR and SCR optimization, durability and validation for engines for various automotive and no automotive applications. Vehicle Test Cell, VTC. There are 6 emissions vehicle chassis dynamometers and 3 mileage chassis dynamometers capable of testing vehicles up to 5,000 kg GVW. Each test cell is equipped to test and check various emission parameters such as hydrocarbon, carbon monoxide, carbon dioxide, nitrogen oxides and particulates as per BS6 and Euro 6 norms and durability and validation. The lab is also equipped for an on-road emission performance. Vehicle Evaluation Lab, VEL. Vehicle Evaluation Lab undertakes key tests including coast down, brake performance, maximum speed, fuel consumption, acceleration and performance, drivability trials, tire noise testing, endurance and durability tests, ABS test, etc. as per the specific needs of the customer on test tracks. Component Certification Lab, CCL. Component Certification Lab, CCL provides services related to certification and homologation of automotive components. As per Central Motor Vehicle Rules, CMVR, the lab undertakes developmental testing, environmental testing, vibration testing, hot and cold chamber, weatherometer, ozone chamber, salt spray chamber, walk-in chamber, etc. for all components for on-road and off-road vehicles. Photometry Lab. Photometry Lab at ICAT is the state-of-the-art facility and one of the finest in the world. Fundamental research is carried out on LED measurement methods, spectroradiometric measurements techniques, visibility and glare, headlamp aiming, conspicuity, telematics, etc. Not only does the lab cater to automotive lighting, but also provides testing and development services to non-automotive applications, which includes domestic lighting and aviation lighting. Materials Lab. Multiple facilities available here in Materials Lab include mechanical testing of rubbers and plastics, coolant test facility, chemical testing of polymers, flammability testing of upholstery, carpet materials as well as inner components, wiring harness for kits used in automotive 2, 3 and 4-wheelers, etc. Fatigue Lab. In order to ascertain the life of products, extensive tests are undertaken by OEMs and their vendors. These tests include durability and integrity assessment of vehicles, systems and subsystems under various driving and environmental conditions. Fatigue Lab in ICAT has state-of-the-art facility wherein you can bring in road to the lab evaluation, multi-axis simulation tables, expositors and various actuators in various simulated environmental conditions make this possible. Electromagnetic Compatibility Lab, EMC. The application of electronics has significantly increased in automobiles over last few decades. In view of this, the electromagnetic compatibility compliance has become of paramount importance both at the device as well as vehicle level. Passive Safety Lab simulates various crash scenarios. This is to ensure occupant and pedestrian protection in the event when a vehicle encounters a crash and the ability of the vehicle structure to absorb the energy of the impact. Some of the services offered are frontal impact crash test, side impact crash test, side pole impact, rear impact test, static rollover, pedestrian protection testing, etc. A notable point is that ICAT was the first organization to set up pedestrian safety lab in India. Tire Test Lab. Tire, being crucial for the road safety, comfort and fuel economy of the vehicle, needs to undergo a comprehensive and rigorous testing to evaluate and ensure its adequate performance. Both performance and rolling resistance evaluation of tires for various category of vehicles is undertaken in this lab. Noise, Vibration and Harshness Lab. A Center of Excellence on Noise, Vibration and Harshness, NVH, is the first of its kind of facility in India to offer services for development of vehicles and components, testing and validation. The lab is equipped with the semi-anechoic chambers with chassis dynamometers and state-of-the-art equipment and instrumentation. Automotive Electronics and Electrical Lab. The AEEL at ICAT is one of the most important labs considering the rapid increase in the use of electrical and electronics in the vehicles. The major facilities available at AEEL are related to electrical measurements, ECU validation, environmental testing, altitude testing, dust and water ingress testing, thermal shock, vibration and shock testing, weather resistance, battery cyclers and motor test benches, etc. CAD-CAE Lab. CAD-CAE Lab helps in design and development of vehicle and its component. Here, components and vehicles are not only tested virtually, but also studied for modification and optimization if required. Apart from virtual testing, it offers other services such as CAD modeling, drawings, fixtures and structure design. ICAT is poised to develop into Automotive Development Center, not only to provide certification services, but also product development services to Indian and global OEMs. At ICAT, we constantly strive for excellence, both in terms of building facilities and building matching skills. International Center for Automotive Technology, ICAT. International Center for Automotive Technology, ICAT. The most populous democracy in the world, the Republic of India is a vast South Asian country with diverse terrain ranging from the Himalayan peaks to Indian Ocean coastline and a history dating back 5 millennia. A cultural melting pot, it is a pluralistic, multilingual and multi-ethnic society which became one of the fastest growing major economies post market-based economic reforms in 1991. A key contributor to this enviable position is the automotive industry, which accounts for 7.1% of the country's gross domestic product, GDP. Located at the northern hub of automotive industry in Manesar, Haryana, ICAT has emerged as a comprehensive technical partner to the automotive industry and renders valuable services such as homologation and certification, developmental projects and testing and automotive R&D projects. The state-of-the-art infrastructure at ICAT is pivotal in carrying out these functions and can
Welcome back, ladies and gentlemen. We will now proceed further for the first technical session of the day, which includes 2 technical presentations. We have BIS official amongst us who will guide us in the procedure and requirements of the upcoming quality control orders on safety glass. All the attendees are requested to write your questions in the question answer section. We will take these questions at the end of technical session. For the first technical session, I would like to introduce our first speaker, Shri Rakesh Kumar. Shri Rakesh Kumar holds a bachelor's degree in mechanical engineering and has more than 8 years of experience at Bureau of Indian Standards with experience of 7 years working at various BIS branch offices. He has also experience in preparation and finalization of product scientific guidelines on certification of products pertaining to the mechanical engineering, transport engineering, production and general engineering departments in Central Marks Departments 3, CMD3 in BIS. Thank you for joining us, sir. I would now request Shri Rakesh Kumar to start with their presentation. Over to you, sir.
Thank you, Devyani. Is it audible?
Yes, sir.
Okay. So, respected chief guest of honor.
Rakesh, sir, can you please switch on your camera? We have shared the request with you.
Okay, 1 second. Is it visible also now?
Not yet, sir. Sir, we can see the black screen only and you are not visible.
1 second, let me try again.
Sir, we can still not see you. Sir, anyway, we will start with the presentation now.
Sure. So, okay, when ready, show my screen. Okay, I will request one of you to please assist me in the presentation because that may not be much handy for me to share the presentation directly. So can you please start the presentation?
Give us a second, please.
Yeah, please. Yeah, thank you so much. So Let us begin with this presentation, which is on the topic quality control orders and BIS certification of safety glass for road transport. This presentation would be covering the quality control orders and the BIS certification aspect of safety glass for road transport as per IS 2553 part 2. Just after my presentation, there would be another presentation on BIS certification for safety glass as per IS 2553 part 1, which would be given by my colleague Shri Aditya Dashi. And in this presentation, we would be covering various aspects of BIS certification along with the relevant provisions of the quality control orders, which governs the certification. So let us begin it. Next slide, please. So coming to the quality control order on this topic, according to the quality control order which has been issued by the Department of Promotion of Industry and Internal Trade, Ministry of Commerce and Industry, Government of India, the safety glass for road transport have been brought under the mandatory certification of BIS, and accordingly the safety glass are required to conform to the relevant Indian standard, that is IS 2553 part 2 and the latest version 2019. Let me make it clear that this standard here, since we all know that the standards are dynamic in nature, and whenever there any amendment comes to the standard or any revision comes to that, then automatically it will apply even for the purpose of quality control order. So according to this quality control order, the safety glass for road transport has to conform to the requirements of IS 2553 part 2 and should bear the standard mark under a license from BIS, which is granted as per scheme 1 of schedule 2 of BIS conformity assessment regulations. This quality control order comes into effect from 1st April 2022. Next, please. Coming to the scope of this standard applies to various kinds of safety glazing which are intended for installations as windscreens or window pans on various categories of vehicles. The categories of vehicles are defined in IS 14272, and for the purpose of this standard, in the case of double windows, each pane is considered as a separate item for glazing. Next, please. Under the QCO, the exemption is also covered, and the safety glass which is used in the vehicle imported in India by vehicle manufacturer under the provisions of Rule 126 of the CMVR 1989 is exempted from the purview of this QCO. Now coming to the certification point of view, Mr. Alok Ji has given a brief of the process for certification. So let me deal it in greater extent. This BIS certification is actually covering the various aspects from the start of grant of license to the operation of license. And as far as grant of license is considered, it is done after assessing the manufacturing and testing capability of the manufacturer through factory visit, and then assessing the conformity of the product sample through the test report issued by a BIS recognized laboratory. In the first visit, which we call as a preliminary visit, we try to assess the manufacturing and testing capability of the applicant, and during that particular visit we also see the competency of the manpower which is engaged in particularly the quality control sector, and then we also conduct the factory testing in the laboratory of the firm itself, and then once they all are satisfactory, we draw a sample for independent testing and send the sample to a third-party lab which is recognized by BIS. And then when the test report comes to us, and if it is satisfactory and is meeting to the requirements of the standard, that is IS 2553 part 2, we grant the license. Coming to the options of grant of license which are available for a manufacturer who seeks to obtain a license from BIS, there are two options. Option one is popularly known as normal procedure, in which the license is granted after ascertaining conformity of sample which are drawn by BIS during the first visit. And in the option two, which is known as simplified procedure, along with the application, the applicant also submits a test report of the product from a BIS recognized laboratory. And then, as I said, that for grant of license purpose, we conduct a inspection. So even if we draw sample for independent testing in this option 2 also, we do not need to wait for the test report of the sample which have been drawn by us during this verification visit. And if the assessment of the manufacturer is considered to be satisfactory, then the license is granted. Of course, the license is reviewed after the receipt of the test report. Next, please. So once the license is granted, it is granted with a defined scope of license, and the new varieties can be included subsequently. The guidelines for grouping, which is available in the public domain under the product manual sector, is followed while drawing the samples for grant of license as well as for inclusion of new varieties. These guidelines for grouping are available in public domain, and even the prospective applicants or the existing licensees can use this if they want to submit for a new license or for inclusion of additional varieties. The product manual, which is available on our website, it contains the sampling guidelines which I mentioned, and then the list of major test equipment which are given for a guidance of the manufacturer, so that he should have those testing equipment in his factory. And it is to be mentioned here that it is only a tentative list and not exhaustive list. And it is imperative to mention here that the purpose of this list is just to guide the applicant or the licensee. And then if any manufacturer wants to deviate from those testing equipment, he should just inform us. And but the condition is that the testing equipment which is different from what is mentioned in the list, it should serve the purpose as per the relevant Indian standard. Then the product manual also contains the scheme of inspection and testing which the licensee is required to follow after grant of license. It also contains the possible tests in a day for the facilitation purpose of the inspecting officers, so that whenever they visit the factories, then they are then the tests which can be done in a day, they are readily available to them for as a ready reference. Next, please. Coming to the acceptability of test report, as I said in the earlier slides, that we send the samples to a third-party lab which is recognized by us. So at present there are two labs, ARI Pune and ICAT Gurugram, which have been recognized for the purpose of accepting the test report. And this is a dynamic list, and for the current status of these laboratories, viewers are requested to please visit our website and get the updated list. Next, please. Post grant of license, during the operation of license, licensees are required to follow a prescribed scheme of inspection and testing and maintain records. The performance of license which is granted by us are regularly assessed by factory and market surveillance. During those factory surveillances, we test the samples of ISI marked product in the factory itself, as well as we draw samples for independent testing. And I would like to mention here that the testing charges of these samples which are drawn for independent testing after grant of license, they are borne by BIS and not by the licensees, unless it is explicitly mentioned, such as for the purpose of, let us say, resumption of marking, in which case the license is under suspension of marking, and then if for the corrective action verification purpose, we are drawing another sample and are sending sample for testing to a third-party laboratory. In that particular case, the licensee has to bear the testing charges. Next, please. Now coming to the scheme of inspection and testing and the levels of control which a licensee is expected to exercise in his day-to-day quality controlling. There are various kinds of tests which are mentioned in the standard, and some of them are to be done on each glass, like marking as per clause 4.1 of IS 2553 part 2, and some of the tests which are to be done after every 6 months for each kind of variety, such as resistance to abrasion test as per clause 6.6 of IS 2553 part 2, or some may be once in 2 years, like the light transmittance test as per clause 6.11. So these all tests and their frequency are decided based on the criticality of the test, the duration of test, including any conditioning requirements and its significance. And the SIT also contains the requirements of test equipment in terms of required or subcontracting permitted. If you see the SIT of IS 2553 part 2, there are many tests which for which we have permitted subcontracting. Next, please. Thank you. So if any questions are there, then we can take up now.
Yes, sir, we have questions from the participants. I will ask you the questions one by one with the concerned person name. First question is from Mr. Suchindran, and his question is, if a manufacturer choose option 2, simplified procedure, whether the plant audit is still necessary for the issuing of BIS license or not?
Yes, ma'am. I would like to reply that even if any manufacturer opts for option 2 for grant of license, in that case also plant audit would be required.
Okay. Next question is from Mr. Ishu Marwa, and his question is option 2, which is a simplified process, applicable for foreign manufacturers as well?
I think option 2 as of now is not available for foreign manufacturer certification scheme.
Okay, sir. These were the 2 questions which we had received.
Okay, then if no any further questions there, then we can go to the next session, please.
Okay, sir. Thank you.
Yeah. Thank you.
Thank you so much, sir, for your informative presentation. Now, I would like to introduce our second speaker of the session, Shri Aditya Das. Shri Aditya Das is the Scientific Officer at Bureau of Indian Standards, the national standards body of India since 2010. He's a dynamic professional with strong analytical communication and problem-solving skills, experienced in working with industry and the government on various key issues relating to the conformity assessment schemes. He has been working closely with the industry and government agencies in facilitating the conformity assessment for a wide variety of products in areas such as steel, textiles, chemicals, food, and agriculture. He also contributed significantly to the conformity assessment framework of BIS and helped in facilitating the implementation of BIS conformity assessment scheme, which as on date covers nearly 1,000 products in the different technological areas. We welcome you, sir. I would now request Shri Aditya Das to start with their presentation.
Thank you so much. Thank you so much for the introduction, and thank you, Rakesh, for the very informative presentation. I'll just start my presentation, and I would firstly, before I start, like to thank ICAT for organizing this symposium, which will be really helpful, in my opinion, in safety glass at large. So I'll just show my screen, share my screen. I hope the presentation is visible at the moment.
Yes, sir, it is.
Okay, so before starting my presentation, Rakesh Kumarji has already covered a lot of the various aspects of certification which will remain common across both the products and products at large. So this is how I have structured my presentation. I'll start with a very brief introduction to BIS, along with an overview of quality control orders, moving on to the BIS certification process, which Rakesh has already touched upon, and talking a little bit about certification of safety glass. BIS, as you know, is the national standards body. It was established in 1947. Then across 52, 88, we had different changes to our organizational setup. In 2016, a new act was enacted, BIS Act 2016, through which BIS was made the national standards body. And according to that, we have framed conformity assessment regulations in 2018, under which we now operate our various schemes, including Scheme 1 and Scheme 2. So our work, especially relating to conformity assessment or product certification, is carried out through a nationwide network headquartered here at New Delhi, and having 5 regional offices at Chandigarh, Chennai, Kolkata, Mumbai, and New Delhi. And there are a number of branch offices and laboratories and a training institute located in Noida, through which we basically execute all our activities. So as I mentioned, we are the national standards body. We are involved in standard formulation, conformity assessment. Section 16 of the BIS Act is an important section from the point of view of mandatory certification, since it is this section which authorizes the central government to promulgate quality control orders or technical regulation for various reasons, including protection of human or animal or plant health, environmental safety, preventing unfair trade practices, and national security, etc. So as soon as a product is notified under Section 16, Section 17 comes into play, which basically prohibits the manufacture, import, distribution, lease or storage or exhibition for sale of any goods or articles which have been notified for mandatory BIS certification under Section 16. Coming to an overview of technical regulations or quality control orders. So as we know, as Rakesh also mentioned, there are quality control orders on glass issued by DPIIT, which include transparent float glass, flat transparent sheet glass, and safety glass, which is the subject of our discussion today. 2553 Part 1 and Part 2, both types of safety glass are under mandatory certification with effect from April 2022 now, as per the extended date. Technical regulations again include QCOs as well as compulsory registration orders, which are under different conformity assessment schemes. So for example, our safety glass is certified as per Scheme 1 of the BIS conformity assessment regulations, under which there is a provision for an inspection and laboratory testing, whereas in case of Scheme 2, under which a number of electronic and electrical products are certified by BIS, it requires only test reports from BIS recognized laboratories, based on which certification is provided. And technical regulations are issued by the regulatory bodies set up by the government or by the ministries and departments themselves. Some important regulatory bodies deal with drugs, insecticides, as we know, the DCGI, explosives, such as the central, as the chief controller of explosives is there. A quality control order has basically 3 main components, which is the standard or essential requirement to which the product has to conform. The scheme, as I mentioned, Scheme 1, Scheme 2, different schemes can apply in a quality control order, as well as it defines who is the certification and enforcement authority. So for example, in case of safety glass, BIS has the responsibility of being the certification as well as the enforcement authority. This is a small graphic trying to encapsulate how exactly technical regulations and standard corresponds to each other. So a standard is essentially voluntary, And it is through a technical regulation that mandatory measures are put in place by the regulators, through which conformity to a standard under a scheme and application of a mark is made mandatory. Section 16 and 17, again, we've discussed earlier. I will not repeat it. There is a penalty for contravention of a QCO, which can involve even imprisonment, fines, and it is a cognizable offense to violate a quality control order. So coming to scheme 1, which is the scheme under which safety glass is certified, under which a license to apply the standard mark has to be applied for a particular manufacturing premises only. So this is something that is important, that BIS grants licenses as per scheme 1 only to a specific manufacturing unit. So if a company has 2 or 3 manufacturing units, all the 2 or 3 manufacturing units will have to take separate licenses. The process broadly involves an initial assessment, as Rakesh ji explained, involving a factory assessment of the manufacturing and testing capability, production process, etc. And the conformity of the product through relevant standard established either through testing in an independent third-party laboratory or testing in the factory premises itself. Even after grant of license, there is a surveillance mechanism in place by BIS, which I will elaborate on in the subsequent slides. So this is what the certification process would broadly look like. So first, of course, which is the Indian standard. Once the Indian standard is known by the manufacturer, application is to be submitted through Manak Online. With presently, as per our rules, now 50% of the minimum marking fee is to be paid in advance. And there are 2 options to apply. You apply without a lab test report, that is option 1, and you apply with a test report from a BIS recognized laboratory, that is option 2. In both cases, there is an inspection of the factory. If the application is found in order, the inspection of the factory takes place. And if the preliminary inspection of the factory finds that all the manufacturing process, the testing facilities, the details of quality control personnel, process flow chart, everything that has been declared in the application is in order during the inspection, then the next step is the acceptance of the scheme of inspection and testing and submitting the remaining marking fee. In case of option 2, at this stage, BIS will grant the license, and the sample which is drawn during the inspection of the factory, whenever its report is received, only a review is carried out, and in case that sample fails, there is a possibility of license being suspended. In case of option 1, even after the preliminary inspection, we await the report of the sample drawn during the preliminary inspection, and once it is found conforming to the standard, the license is granted in that case. Important to explain that even if the sample fails the first time, it is not necessary that BIS will reject the application. There is the practice of course, offering one more chance for an improved sample to be tested. So as I mentioned, even after grant of license, BIS maintains surveillance on market and factory basis to ensure that the product remains conforming to the Indian standard. So surveillance visits are carried out at the factory premises. If it is found satisfactory, then normal operation continues. If it is found unsatisfactory, there are again different options that come into play. If it is a major non-conformity, it may lead to suspension of the licenses, and if the licensee takes corrective action, then normal operation can be allowed to continue. And if it is not a major non-conformity, then again corrective action has to be taken, but normal operation can be continued. The other aspect of surveillance is testing of samples from the factory and the market. Sample failure, if there is a first failure, then corrective action is to be taken, although normal operation can continue. However, in case of consecutive failures of samples, suspension can be imposed, and it is only after corrective action is informed and verified by BIS that suspension is lifted and normal operation can continue. If corrective action is not informed or not taken or is not satisfactory in the assessment of the Bureau, then it may even lead to cancellation of the licenses after a particular time period. All information relating to BIS certification is available in the public domain. License related information for domestic manufacturers can be accessed through manakonline.in, while foreign manufacturers details are available in the FMCS section accessible from BIS website. Again, laboratories which are recognized by BIS or BIS's own laboratories, that information is available on BIS website, and you have to enter the Indian standard at the relevant checkbox, and that you will be provided with a list of all the labs which have been recognized or established by BIS for that particular product or Indian standard. As I mentioned, the scheme of inspection and testing, it is one of a set of guidelines and documents which are part of a larger document called the product manual. It is a guidance document which is meant to facilitate the certification process, and it is not a prerequisite for someone to apply for a license, since in case of many products which are coming into certification for the first time, BIS works with the industry to develop this product based on actual industry practices and the industry realities. Product manuals again are available in the public domain and can be downloaded from BIS website. So the basic features of a product manual are it reflects the raw material requirements given in the standard. It reflects what would be the sample size required for testing in the laboratory. It provides an indicative test equipment list, which is not an exhaustive list, it is only given there for guidance. It also defines how BIS is going to structure the scope of the license, which will be clearer once we see the product manual of safety glass part. The product manual also includes grouping guidelines, which can allow grant of license for multiple varieties without testing each model. So only certain representative varieties from each group are tested, which leads to reduction in the cost and time required for testing. Scheme of inspection and testing is something that has to be followed by each licensee after the grant of license, which includes a set called levels of control, which means that the frequency and of various tests which are specified in the standard has to be followed by the licensee. There is also an option of the licensee also defining their own levels of control. BIS in the SIT defines the subcontracting permissions, which mean that for all of the tests given in the standard, the licensee need not develop in-house facilities. For certain specified tests for which subcontracting is permitted in the SIT, that the licensee can outsource or subcontract those tests to BIS recognized laboratories, but the frequency given in the levels of control will still have to be followed. The fee structure, again, it is again common for across product. For application fee, inspection fee, annual license fee is 1,000 rupees. A renewal fee is given. Marking fee has to be paid annually in advance and at each renewal. For 2553 part 1, this is the marking fee structure. 5.8 rupees per unit, where unit is a ton, and minimum marking fee 66,000 for large scale and 53,000 for MSME units. So which means that a large scale unit will have to mandatorily pay at least 66,000 rupees to BIS as marking fee, while an MSME unit will have to pay 53,000. However, if the calculated marking fee, which means the 5.8 multiplied by the actual production in tons, exceeds 66,000 and 53,000, then the higher that calculated marking fee has to be paid to BIS. So safety glass part 1 for architectural, building and general uses has been under BIS certification on voluntary basis for a long time. There are around 40 odd licenses in place right now, and 30 odd applications are also in process. So the standard prescribes the requirements, methods of sampling and test for safety glass meant for general purposes, such as for architectural, furniture, display boards, railway coaches, earth movers, lighting fixtures, parts and components of appliances, equipment and machines, etc. So I'll move to the product manual for safety glass, which I have already discussed in some detail earlier. So this is what the product manual looks like. It again has a reference to the product, to the title of the standard, the number of amendments, raw material. There is no requirement here. The possible tests in a day that can be carried out. It is for the benefit of the certification officer as well as the manufacturer during an inspection. So this is what I was talking about when I was talking about the scope of the license. So for safety glass, we have mentioned that the type of the safety glass that is manufactured has to be mentioned in the license. So roughened or laminated. The nominal thicknesses that the manufacturer is able to manufacture has to be mentioned, as well as the applicable optional requirements, because there are a number of optional requirements given in the standard, and based on the optional requirements for which the product has been tested and for which facilities are available, those can also be mentioned in the scope of the license. So the grouping guidelines for safety glass part 1 looks something like this. It is based basically on the nominal thickness and the type of the glass. So we have said that the highest and the lowest nominal thickness sample should be drawn for testing. However, separate samples to be drawn for toughened and laminated safety glass. And we can grant licenses for all the thicknesses in that particular range. But the manufacturing and testing facilities have to be there with the applicant or licensee. And when BIS does surveillance inspections, BIS will attempt to draw wet samples of all varieties which are covered in the scope of the license. This again is an indicative list of test equipment. I'll rush through it. This can be used as a guidance. And this is what the scheme of inspection and testing looks like. So it says that each licensee must maintain a laboratory, must maintain calibration, must maintain records, must pack and mark the product as given in the standard, and must mark the standard mark, which is the ISI mark, on each piece of safety glass, which is conforming to the Indian standard. Control unit is defined in the SIT as the safety glass of same thickness and type, manufactured under similar conditions in a day, and also mentions that in the beginning of production run, each control unit shall be tested till 5 control unit pass, and thereafter every 7th control unit shall be tested. So in addition to that, the various tests, the frequency is given. For thickness, for example, 5%, but not less than 5 pieces have to be tested from each control unit. For dimensions, it is the same. And for different tests, similarly, frequencies have been defined. As per the request of the industry, this has by and large been aligned with the sampling plan given in the standard. So with that, I would conclude my presentation, and if there are any questions, I will be happy to take them.
Yes, sir, we have few questions with us. I will take them up one by one. First question is from Mr. Ravi Bhushan, and he wants to know, during the renewal, is it required to perform the testing again and during the time of which happened during the first license?
Okay, so no, renewal per se does not have anything to do with testing. Testing, as I mentioned, will be carried out once you have a license, because you're talking about renewal. Once the license is there, then BIS itself will conduct surveillance by drawing samples from the market and samples from the factory during a factory inspection and get it tested in laboratories. So in that case, renewal has nothing to do with testing. For renewal, you only need to submit a renewal application with the requisite fees and the requisite documents such as production data, etc. Within the specified date, which is usually 3 months before your license is due for renewal. I hope that answers the question.
So next question is from Mr. Gaurav Jha. Does online portal is available for the foreign factory applicants as well?
No, unfortunately for foreign manufacturers, the process is still offline.
Okay.
But you can download the application form and everything is available on BIS website, but an online process is still not established. BIS is working on that.
Okay. So next question is from Mr. Shekhar Saraf. He wants to know whether every year the plant audit and testing is required.
So once you have obtained a license, it is BIS's responsibility to carry out regular surveillance. So it is not your basically the responsibility is BIS's. BIS will attempt to come to your factory or draw samples from the market specified number of times each year. It is not mandatory on your part. It is a responsibility of BIS to do that.
Okay. So next question is from Ms. Sonali Tambolkar. She wants to know that in a BIS license for safety glass, how to find the details of the product approved by BIS.
I'm sorry, could you repeat the question? Your voice was not clear.
Sir, in a BIS license of safety glass, how to find the details of the parts which has been approved by the BIS?
Okay, I'm not sure I understand the question, but assuming that you're saying that which types of safety glass have been approved. So in the license, there is a schedule of license in which the scope of the license is defined, and as I just showed earlier, in the product manual, the manner of defining the scope is defined. For example, for safety glass part 1, the scope of license will include whether it is toughened glass or whether it is laminated glass, and what is the nominal thickness of glass which is covered in the scope of license, as well as which optional requirements are covered. So the scope of the license will be defined in the license document itself.
Okay.
I hope that answers the question, because I didn't quite understand the question itself.
Okay, sir. The next question is from Mr. Sumit Popley. He wants to know what is the procedure to change the scope.
Okay, the procedure to change the scope is, again, you have to apply with the requisite fee which is there, and you have to apply through Manak Online only. Usually to add a new variety in the scope of license, if it is already covered through the grouping guidelines, like for example, you were manufacturing number of thicknesses of toughened glass, and now you want to add a new higher thickness of toughened glass, you have to basically get the, as we mentioned, the highest and lowest variety tested, and submit and get the tested from a BIS recognized laboratory, and along with the test report from the laboratory, you have to submit an application for inclusion to BIS through Manak Online with the requisite fee, which I believe is 5,000 per variety or each group of varieties. And based on your application, BIS will process your request for change in scope of license and will issue an endorsement to your license with the modification and with the changed scope. So that is the procedure to apply for change in the scope of license.
Okay, sir. So we have few more questions with us, but due to time limitation, we will not be able to take them now. We will separately mail it to them, and you can revert them on mail. And if any of the delegates have any more questions, you can write it to us separately, and we will take up to the BIS scientist. Thank you so much for your presentation, sir. It was quite knowledgeable for us.
Thank you.
We will now proceed further for the second technical session of the day, which includes 2 more technical presentations. We have industry and academy experts amongst us who will guide us on the basic fundamentals and upcoming technologies of safety glass. For the first technical session, I would like to introduce our first speaker, Mr. Rahul Nikanj. Mr. Rahul Nikanj brings with him an experience of more than 20 years, spanning across multiple disciplines of glass processing, starting his professional journey from core of production shop floor to leading the development of advanced processes and equipments for automotive glass manufacturing. He possesses his PGDA in operations from Pune University after graduating from State College of Engineering, Haryana in Mechanical Engineering. As Unit Head in Production Technology and Project Department, Asahi India Glass Limited, he is leading the growth of the organization by introducing new technologies in products and process development for advanced glazing and its applications. His specialities include utilizing both qualitative techniques and improvement in productivity, quality, and safety, and implementing low-cost automations, robotics, and cost reductions through alternate sourcing. He is also contributing in the journey of digital transformation for the organization by leading IoT implementation for shop floor analysis. We welcome you, sir. I would now request Shri Rahul Nikanj to start with their presentation.
I hope I am audible.
Yes, sir.
And is my screen visible to the audience?
Yes, sir, it is.
Okay, I just need to make this picture mode. So thank you for this introduction. So good afternoon to all distinguished panelists and the members from the ICAT and speakers and my fellow colleagues. Thank you for giving us this opportunity to showcase the advanced technologies that are prevalent in automotive industry and also are being offered by AIS in various capacities and globally competitive costs at right quality. So I'll begin my presentation on this with the note that there will be a lot of innovations which are being seen in this automotive space, and we are able to implement it in due course of time. So my objective through the presentation is to apprise you about the current facility of AIS in short, and I will also give you some details on the automotive trend drivers and the regulations are being followed by the industry. Then we'll also talk about the kind of benefits that are possible by using these advanced glazings, and then I will also brief you about how these different technologies are prevalent in various component of the glass, whether it's a windscreen door glass or the back doors. And some of these advanced technology I'll talk about are offering the solution by way of interlaying, coating, as well as we'll also discuss about some of the smart windows which are switchable to permit light as per the request. And then we'll also talk about lightweighting of the glass and the glass which offers acoustic insulation. And there are glass which offers a high level of telematics by the introduction of the antenna on glass. And there are other technologies which are providing safety by way of giving the driver the display of the instrumentation plus cluster right in front of him through the HUD. And then we'll be closing this presentation. Moving forward, to talk something about the AIS, I hope everyone is well aware about the market position and the respect we have in the automotive industry. So this is a joint venture set up by the Labru family along with Maruti Suzuki India Limited and Asahi Glass Japan as a promoters, with a shareholder equity pattern of about 55.5%, and the rest is public. So AIS with its 6 subsidiary or the associate companies today is one of the largest integrated glass company in India, with significant presence in the automotive and architectural glass value chains. And we can identify them as automotive glass, architectural glass, which includes float, mirrors, soft coat, hard coat, and architectural processing to the retail market with the consumer glass. So we have clocked about 26,000 million Indian rupees of sales turnover in the previous year. AIS provides unique advantage to the customer through its location, product, and process flexibility. So we are now spread very almost near to every large OEM in India, and we offer the product capability in windscreen, door glass, and back door through all the locations. Thus, it's a flexibility to provide any customer from any location. So that is our key feature. And we have global engagements with our esteemed JV partner Asahi Glass Company. We can tap all the very best technologies from rest of the world and from the core of Japan to offer here in India. And we follow all the global quality standards and certification, be it IS 2553 or EC regulation or American standards of DOT or the China standards of CC and for the GCA countries as well. AIS product offer the basic products in laminating and tempered. So you all know about them in detail, but there are also value-added products in our offering. So we categorize them in various use of application, the form of comfort, fuel reduction, visibility, environment, communication, and coatings. So before making some brief description on these technologies, so let us see that the global automotive trend drivers in the time to come. So we also strongly follow how the world is moving toward making the world greener, cleaner, safer, with their objective of carbon dioxide emission reduction. So in the time to come, we'll see the new European driving cycle leading to a 95 gram per kilometer of the CO2 limits. And then in the decades to come, there will be the adoption of worldwide harmonized test protocols, which will demand further 15% reduction of carbon dioxide reduction, and then and in future this will also be required to reduce to 37.5% in the time to come. So there are other drivers and regulations. Eventually, this would lead to the zero emission vehicles. So those policies will be mandated in the time to come. So this is right now. It's also in the cards with the government discussions. Then there will be zone regulation in various countries going forward, and we all will see an urban mobility. And also with this pandemic, we have seen those changes as well in the urban mobility. Then the regulations will also be drafted for the electric vehicle to improve the efficiency in their mileage. So we take a snapshot and we see that how these regulations are driven in India. So we have recently leapfrogged from BS 5 norms to BS 6 norms directly, in this in the last year of 2020, and in next 2 years we will see the implementation of CAFE 2 norms, so which will limit the CO2 emissions to 113 grams per kilometer, and then which will eventually be validated by the real driving emission test and the harmonized test protocols in 24. So how can we reach to our objective through glass? So there are a lot of glass innovations. So whether it is coming from the windscreen or the other door glass panel, so all these solutions will lead to the benefits to the society at large and the environment, and to the user this gives the better mileage in terms of fuel efficiency, and also gives the comfort to the occupants. How this is delivered? So we analyze the heat load which is coming to the cabin, whether the vehicle is running on the road or is parked under the sun. So all these solar radiations are reaching to the glass surface, and we can divide the component of the solar energy into the energy which is transmitting through the glass and reaching to the cabin, and the energy which is reflected from the surface of the glass, and the energy which is absorbed by the glass. So if we talk about a 100% solution on the bicular glazing, and with the application of special solar control techniques, we can evaluate, and also through our simulation can say that these can give about 400 watt per meter square of relative heat gain reduction into the cabin, which is close to 22% if we implement these solutions available in right perspective. So these benefits can be validated by use of the climate control chamber. So AS is following that initiative along with the OEMs to get these glazing validated in the closed environment as well as in an open environment test procedures as well. And I'm sure that ICAT offers this kind of service to all the OEM, but we see that there is a gap in visualizing this benefit can also come from the glass. So by way of by organizing a test procedure with the standard glazing, and then by the combination of solar control, we can evaluate the test which can show us the results as what we simulate is of 9 degrees Celsius of reduction in surface temperature of the steering wheels and dashboard and other surfaces in the car, and there can be 3 degrees Celsius of reduction in the cabin temperature by use of this technology, which will eventually lead to 2% of the improvement in the fuel economy, because since India being a tropical country, so there will be a use of air conditioners all the time during the good length of the day. So under test conditions, so we can say that this is this can give up to 2% of the improvement in the fuel economy. So this can then be compounded to a 6 gram of carbon dioxide reduction by the use of these technologies. So so it's a win-win situation for the user as well as industry to adopt these advanced glazings in the automobile. Now we specifically come to see that what are these technology is available in laminated windscreen. So in lamination, we can control the solar radiation by way of interlayer, by way of changing the glass to advanced glazing, and by leveraging the benefits of coating in the glass. And in laminated windscreen also offers the better or the quieter cabin by use of acoustic glass. Then there are possibilities to reduce the weight. We'll talk about them in the later half of this presentation. Then laminating glass can also provide the safety in terms of bringing clarity in terms of projecting the information from the information cluster to the directly in front of the driver. So it has been seen by the surveys that a 3-second dip of your eye movement can lead to some kind of injury or damage. And the laminated windscreen also offers the rain sensor glass. So with the activation, as soon we see the rain or the raindrops are falling onto the glass, so the wipers are automatically operated. So this adds to the safety in immediate demand. Then there are glasses where the surface is enhanced to repel the water to find a greater visibility. And also there are different weathers where we need to de-ice the windscreen. So there are solutions to demystify the glass. And also the glass is the laminated glass also finds its use to provide the multi-glass antenna embedded in the glass. Door glass also offers a similar kind of solution, but in addition to that, we can offer the modular assembly in the fixed glazing of side window as well as in the quarter lights. So those will be, this adds to a good appeal, and it also saves time in the assembly line of the car production. This can further be added with the bright works for a good appeal. Nowadays we see a lot of usage of bright works in the trim line of the vehicle or the belt line of the vehicle. So we provide this as an insert molding along with the glass. So to summarize that all these applications use, so for every used application, so there is a solution for that, whether it is a comfort, environment, or safety, communication, fuel economy, or the design. Now we throw some light on how these technologies work. So if we talk about the laminated glazings, whether it is a windscreen or also it is offered in laminated door glasses as well as in laminated sunroofs. So same kind of solutions can be applied to control the solar radiation. So one such design offers a special interlayer which has dispersed IR cut particles in it, so which has the ability to absorb the radiation in the wavelength more than 1000 nanometer. So this particular wavelength is responsible for heating the cabin inside, so which is absorbed by these IR particles which are embedded in the interlayer, and thus offer about 10 to 15% of reduction in the heat load. And if we measure this benefit, we can see that there will be we can reach to a comfortable ambient condition inside the vehicle 7 minutes earlier in comparison to the normal glazing. So there are other benefits also, which I was explaining in the previous sections, compounded with it. The solar control, so we just have seen that how it is being offered in laminated. So there are the options to provide the solar control by changing the glass, the optical properties in transmission through the glazing by the manufacturing of the glass. So this comes from the glass as a property. So there are different types of glass like solar green and a unique product of dark green glass is also now available, which offers visible light transmission within the permissible regulatory norms of India, which is more than 50% in terms of for the door glasses. So these tinted solutions offer close to 58% of total solar transmission against 71% in terms of normal glazing. So this is also about 10 to 15% of the heat load reduction through the side door glass comes as a benefit. And we very well know that the use of film is restricted by law. So this gives an optimal solution to an automotive industry to incorporate this feature. In the third type of the technologies which offer the solar control is by way of coating. So there are metallic coatings which are applied on the glass. So whether it is a windscreen or a door glass, so these are tungsten based coating which are applied on the glass by various processes of soft coat and hard coat. The thickness ranges from close to 250 nanomicrons, and we get the light transmission above the norms of 70%, but there is a huge benefit in terms of reducing the total solar transmission. And the advantage is that these are of non-absorbent type, so most of the energy is reflected back into the space. So there are research available which says about that with every 400 watt decrease in load, we can get the benefit of 4.4 km/liter in terms of increase in mileage. So these are validated through various laboratories. We were in the previous part of this the presentation, we were talking about the benefits from the IR. So the same glass can offer the reduction of UV radiations which are harmful for some of us with the sensitive skin. So AS shares its technology with through the AGC to offer this world the super UV cut tempered glasses. So in a normal conventional UV blocking UV cut glass, these offers about 85% of UV cut reduction, but with the coating of a high performance UV absorbing layer on a UV cut glass, we can offer a super UV cut glass which offers 99% of UV rays reduction, which very equivalent to the laminated glass. So that means 100% of the 360 degree of the glass space can give us a protection of from the UV, which is has also been rated equivalent to the SPF 50 according to the standards. There are other technologies in laminated space. So we'll first talk about the wired heated glass. So these glasses have a wire embedded inside the interlayer. So one may say that if the wires are embedded, then what will happen to the visibility? So my dear friend, this does not affect at all in terms of visibility. We can't see these wires because of the special design of their size. These are 8 microns in diameter, and at a distance of 8 meters, one can hardly see the presence of it. So this offers a solution in terms of heating the windscreen for demystifying it. And this type of application helps to add a specific feature for EV, where there won't be any engine anymore, and then the glasses are required to be heated. So this finds a suitable space in the electric vehicle as well. There is another cost-effective solution which can be applied locally. So there is a small area of the wiper which are heated underneath the windscreen. So we can see through this simulation. So in 5 minutes, the glass temperature around the wiper can reach up to 42 degrees Celsius. In 10 minutes is up to 50 degrees Celsius, good enough to wipe off any snow or mist in the glass and offer an immediate mobility to the driver or the passenger. Then comes another advanced, highly innovative glazing for an automotive perspective. So this is, we have seen this, the use of special films, light control switchable films in the architectural space. So taking the inspiration from that utility, the same technologies are now being offered in automotive, where we can switch the transparency to different levels on the switch of a button. So there are various technologies. So one is PDLC, the electrochromic, and the more prevalent with the automotive is the SPD. We call it as Wonderlight in collaboration with AGC. So these SPD films are specially, SPD stands for the suspended particle dispersion for that matter. So these films are embedded in the standard interlayers and offered as a laminate, and the bus bar terminals are provided across the glazing to make it enable for an on state or an off state. So in off state, these offers a dark mode. So without utilizing any energy, the transparency, beg your pardon, the transparency is limited to 5%, and the heat load is also widely regulated, only up to 17% of the total solar transmission. And to have a panoramic view, we can switch on this glazing, which further enhances the transparency of the glass to 40%, and still a cooler environment can be felt through the film. So these are now finding a good adoption in terms of in solar, in sunroof, as well as in the fixed glazing behind the C pillar. There are solutions also to offer the glass which are lighter in weight. So all of us know that with the 10% reduction of the vehicle mass, so we can really increase the fuel economy by 6%. Though glass shares only a 2% of the total unladen weight of the vehicle, but there are solutions available which can provide close to 4.8 kilograms of saving in comparison to the standard glazing we see in a vehicle. 1.7 kilogram can be saved in windscreen, and 3 kilogram put together can be saved through the door glasses. So this offers close to 11% of weight reduction from the scope of glazings, and significantly this gives 0.28% of the fuel economy by that standard, improvement in the fuel economy by that standard. So with lightweighting, there is also a demerit that with the reduction in the thickness of the glazing, there will be a tendency of more noise that can enter into the cabin. But no worries, there are solutions to further limit the noise across the glazing by use of special interlayers in the glass. So in comparison to standard interlayers, so these are these acoustic interlayers have we can identify it as in 3 layers. So the core layer, which is between the 2 outer layer, is special in terms of its density, does offer a damping of noise vibration. So these are validated in the laboratories at component level, and are also validated by the OEMs in during their vehicular tests on a real-time basis. So close to 5 decibels of sound transmission loss is seen by use of these acoustic glass. So within the range of 2000 to 4000 to 5000 frequency, and this is the particular range which is sensitive to the human ear. So moving forward, we have talked about the tempered glazing. We all see about the tempered glazing around the door glasses, but there are also solution in terms of laminating the side lights. So these offers the same kind of solution in solar control acoustic as we have seen in other laminating glazing, and the extension of this multi-layering is also seen from the perspective of safety when we talk about the anti-theft glass or the bulletproof glass for that matter. Talking about the use of glass in telematics, so there are solutions available which offer the embedded antenna in the windscreen. So if we are using any kind of a metallic glazing which offers the electrostatic shielding, thus limiting the electrical transmission into the cabin. So when applied on the glazing, it really can enhance the reception of the signals through the glass, and which can be connected to any platform of 4G or 5G, and thus provide good connectivity between vehicle to vehicle or the other media device we use in the cabin. A low-cost solution of providing the good reception is is also available, and it is really printable on the glass on fixed. So by the adoption of this technology, we can really do away with any of the external antenna which are susceptible for the damage or pilferage. So so this is also a very niche product finding good interest with the customer. Water repellent glass offers a high level of clarity through the side windows, and it comes, the solution is offered in combination with the coating applied on the door glasses, and the IRVM suppliers also adds to this by applying the water repellent coating on their mirror. So it greatly enhances the visibility on a rainy day. I also personally experience the need of this type of technology to be made available in all the vehicles because of its prime offer of the safety for the passenger, not only for us but also for the people who are walking on the road, the pedestrians. This technology is, I mean, as an OEM, the special coatings are applied on the glass, which reduces the surface tension of the active surface, and thus offers a greater repulsion to the water molecules. In a nutshell, the cohesive forces of the water molecules are more than the adhesive forces which present between the two surfaces, the water droplet and the glass. In the space of providing safety, as in the earlier part of the presentation, it was also mentioned about the increasing adoption of head-up display. So this is also one of the advanced glazing offered in automotive in various. There are different kind of solutions to offer this, but as a glass, we can provide this niche product without the use of any external film or some local solution. So the complete glass can act as an area to project the information within the norms, and we can always get the alerts right in front of the eye, whether it is in terms of speed or taking the idea from the navigation. So this technology, what is the difference between a standard laminate and a laminate with an HUD? So if you project, or we have seen the images reflecting within the glass, we see that due to the use of different layers of the glass, the reflective images are having an overlap reflection, so can appear like blurred or ghost-like images. But these special techniques of using the wedge-shaped interlayer within the glass, so this reflection can brought to the normal and thus can completely keep able to provide a sharp image to the driver with good brightness. So with all these technologies in research, so there are many more. So with the paucity of time, we have limited our presentation to showcase only the technologies which are finding now greater importance with the customer. So we owe all our credits to the customers who have shown the good confidence and faith in AIS, and this will, since we have about more than 70% of market share, so almost we are trusted with every OEM in the country, and also have a remarkable presence now in the export market as well. With this, I come to the end of this presentation, and thank the organizers for this wonderful event of giving us the opportunity to showcase the advanced glazing through the forum.
Thank you so much, sir, for sharing such in-depth knowledge with us. We will now proceed for the second technical presentation of the session, which will be given by Dr. Devendra Kumar. But before that, let me take a minute to introduce Dr. Kumar. Professor Devendra Kumar, MSc Physics, MTech and PhD, has started his independent teaching and research career after joining as lecturer in 1984 at IIT BHU. He was elevated to the post of Reader in 1990, Professor in 1998 and Professor in 2012. He served as Head of Department of Ceramic Engineering for more than 6 years during 2006 to 2009 and 2016 to 2019. He retired from the service of IIT BHU in December 2019. Before joining IIT BHU, he served as research engineer at Advanced Center for Material Science, IIT Kanpur, after completing his PhD in 1981. During his teaching and research career of 35 years, he worked in different areas of ceramic and glasses. He innovated a unique class of ferroelectric glass ceramic materials with tailored phase, microstructure and dielectric characteristics, example pure and solid solution, ferroelectric phase. Professor Devendra Kumar has published more than 290 research papers in reference with journals proceeding and guided 26 PhD and 86 MTech students for their thesis. He has been granted several projects by DST, CSIR, DRDO, and UAGC. He was awarded Material Research Society of India Medal in 2002. He is a life member for different professional societies and is fellow of Institution of Engineers and Indian Institute of Ceramics. Recently, he has been featured among the top 2% scientists worldwide and top 1500 Indian scientists on the basis of an international evaluation of his research contributions. We welcome you, sir. I would now request Dr. Devendra Kumar to start with his presentation. So we have sent you a camera opening request.
Yes.
Will you please accept it?
Am I audible?
Yes, sir, you're audible.
Okay. First of all, I would like to thank ICAT for giving me a platform to interact with the industry people. I am having interactions with the glass industry on various platforms, AIGMF and the Bureau of Indian Standard. I am chairman of the Flat and Coated Glass Committee of the Bureau of Indian Standard. So with that, I am in interaction with the industry. Here, I bought Mr. Rahul has given many innovations in the safety glasses for the automobile industry. But what we see that the glass industry, what we are talking, that is the integrated technology. We are having the integration of other technologies with the glass and improving the performance and efficiency and application of the glasses. But what we find that in the glass itself, there are we can do many innovations. if we see the history of how the glass has developed over a century, we can see that from the medieval ages that we know about the glass, but about the strength of glass, the many advances has taken place over the last century, and we have, and that's why with the strength of the glass, I am basically trying to convey the message that how the innovations, how the thoughts give rise to maximize the strength of the glass. In the beginning, in this initial inaugural session, the Mr. Alok had given that the glass also protects during side collision or the rolling or collision. So it all depends on the strength of the glass. So how this we can maximize the strength of the glass, that is the purpose. And so they are simple concepts. I may be using some, what you can say, there are some mathematical equations, but they are necessary to try to understand the basic, what is the basic philosophy with which we go with the technological development. So here, I would like to share my, my slides are shared?
Yes, sir, we can see the slide,
Hello.
but yes, sir, we can see the slide, but I request you to show the slide in presentation mode.
Yes, yes, I am doing. Okay.
Yes, sir, it is okay now.
So here, now, suppose we just think of the, now we have to focus on the glass. So there are few questions everybody may come in their mind. Is glass a unique material? There is no replacement, or some alternative materials are there. Whether we prefer to use the glass in place of articles made from other materials, is glass is safe to use? Are we safe from the glass during breaking or after? And finally, when the safety is guaranteed, will we use the glass? Now, what we find, there are answers to the questions are mixed. For many applications, glass is unique, like transparency, some plastics are there, but many applications are there. So there may be no alternative. So we have to use for those applications. I am talking in general, not the automotive, but in general. So if what we find that suppose we have two same article made of glass or made of other material, what we would like to prefer? Most of the cases, what we can say that we would like to use the glass because having it is having many attractions, the gloss, etc. in comparison to other. So our answer will be yes. If so, we have the alternative materials, but we would like to use the glass. Only thing that the question comes that about the safety. If the glass is safe to use, the question will come in the mind that glass is not safe to use because it breaks easily. So only thing that safety, whenever we talk of the safety of the glass, we always talk how it breaks. If so, what we find that whenever glass is breaking, it may harm us, or a broken piece of the glass can also harm us. So that is also the question is that the glass, if it until it breaks, it is very safe to use, and we would like to prefer to use the glass. But if it breaks, then during breaking or after, because the glass articles are having sharp edges. If it is lying on the road, if it is lying on the some field, they are having the sharp edges. They are not blunt. So even a small piece of glass on the road may injure us. So what we have to do? Well, so we have to know that how the glass breaks. The glass breaks by impact, by bending, or thermal or other shock. The other thing is that whether we can say that, okay, up to this load, glass will break. After that, glass will not break, and this glass will break after that load. Again, they know the breaking point of glass articles are also not definite. Then what to do? So that question, all these doubts and knowledge, the scientists are working for last 1 century. Now the question is that when we change the answer from no to yes. Again, the answer comes with when we go from the scientific mind, we say that we can change the answer from no to yes, and that is happening, and that's why the usage of glass is increasing day by day. And the last 2 decades also it had grown enormously. So the scientists and technologists try to change the answer from no to yes, and there is role of standard organization, because when it is a consumer product, so it is not that once make the glass we say that okay, this will not break, but the standard organization has to guarantee that glass articles are safe under particular environment and specific purpose. And with that protocol, the manufacturers try to make their production per industry. So all the segments are important. The scientists are working that how to have the glass which are safe, and then it does not break during this service, or even if it breaks, it is not hazardous to us. So here, what we say, the safety glass, we say that we will prefer to use the glass articles if it is guaranteed that it will not break during, and they are safe as per standards. So what we say that safety glasses are, they like safety goggles, safety in the cars, because they protect us from the hazardous environment. They don't break under service condition, and even if they break, they are not hazardous. So that are the conditions for the safety glasses, and how the advancement of this took place, which has lead to such large usage of the glass. So if we go back to some history, that what we say, the glass, we have to understand the fracture behavior of the glass. The glass is a brittle solid, fracture after reversible elastic deformation without any plastic deformation. So that is the basic thing. In the metals, they fracture with plastic deformation, and they absorb the energy. So there are 2 things. One is the strength, and the second is the toughness. The toughness of the glass is poor, although strength may be high. So what the question came in the mind of this scientist, it is really true that glass is safe to use. Wait 1 minute. Twice. So the question came into the mind of the scientist whether the theoretical strength of the glass is higher than the actual strength of the glass. So from the fundamental point of view, they have started calculating the theoretical strength of the glass. And what they find that the theoretical strength of the glass is 1/15 of the practical strength of the glass, and that is mostly equivalent to 2000 megapascals. But what we find that normally the actual strength of the glass is hundredth or 1000 times lower than the yield strength of the glass. It is in the range of 2 to 200 megapascals. So what we find that the glass articles, they are failing, but their naturally their strength is 100 or 10 times higher than the actual strength of the glass. So what we can do that, if we know that how it fails, so there is a chance of improvement. If this answer does not come, then somebody is hopeless. But there is a hope that we can increase the strength of the glass by the to maximum extent. So again, the question came that what is the reason for the low strength of the glass? And again, they have find the solution that the glass is a hard and brittle material. So any rubbing effect, any post-usage effect, there are many fine flaws, cracks on the surfaces of the glass. And those cracks, they amplify the applied stress. Suppose the load is small, but at the point of the crack tip, the glass is, this load is amplified. So that is multiple times higher. And whenever this load at the glass tip is greater than the sigma maximum, the crack will open up and they will fail. And if it is less than the sigma maximum, they will survive. And the second thing is that brittle failure, the failure is catastrophic. Once this failure is, the propagation of crack starts, it propagates at the speed of sound. So the failure, so the basic thing it came that the failure will occur because of the stress concentration at the failure tip. Again, further advancement that people have worked out that the shape and size of the crack is also important for the failure of the glass. So when we say that the failure, so the predictions, what people have found that mathematically, the scientists, what they do the predictions mathematically and testify those predictions experimentally. So what they find that the shape and size of the flaws on the surface of the glass produced during manufacture or post manufacture, they are deteriorative to the strength of the glass. So once it has come that, the second thing, the most important comes, the observation came with the Griffith in the last century 40s or 50s. He has extensively worked on the strength of the glass. So what the outcome of that is, we can understand by the simple equation. This when the crack opens up, how the energy is changing. Now, two things are there. When the load is applied, there is some strain energy which is developed within the glass, and so that strain energy is developed. But in opening of the glass, that energy is consumed by creation of the surface. So there are two factors which are competing with each other And those two factors, the strain energy and the surface energy. And so what we find that if the crack side, the crack side, what we find that there is some critical crack side for a particular load, that below, if this side of the flaws are less than the critical size, the glass will not fail. If the size is more than the critical size, the glass will fail. So it is so we cannot avoid this, the surface flaws on the glass, but we can say that if the flaws on the glass surface are less than the critical size, we are safe from that for the breaking of that glass. So here, what we find that, so there are two factors. One is the applied stress, and another factor is the size of the. So now if we take the two factors in common and work out with the single factor, what we describe that the one parameter which is known as the stress intensity factor, that combines K1 is equal to sigma square root of pi by C. Now what we say that so what if, because of the presence of the flaw and the application of stress, there is some stress intensity factor. So whenever this stress intensity factor approaches the critical stress intensity factor, the glass will fail. So that is the criteria. Once we know the criteria, so condition for fracture comes that. So once we know this thing, that the critical stress intensity factor, it is having two terms. One is the elastic modulus, and second is the surface energy. So here, so this basic knowledge, presently whatever we are finding here for the strength of the glass, we are using this basic knowledge for the technological exploitation. So what is first thing is that, now what we can conclude that the fracture toughness or theoretical strength of glass is 10 to 20 times higher than the practical strength. So here there is a lot of scope for increasing the strength of the glass. So this is the one fact for technological development. Second thing is that larger the critical stress intensity factor, higher will be theoretical fracture strength. So safe limit can be extended. This is the most important part. Safe limit means what is the safe limit for higher strength. So this is the natural strength of the glass. So what we say, we can select a composition with higher bond strength and higher surface energy. So that is the basic thing, that whenever we are working with the composition of the glass, if we want to work for the safety glass, we have to work for the safety glass with total bond strength is high and the surface energy is also high. The next thing is that fracture occur, the size of any single flaw on the surface of glass has size greater than the critical flaw size for the service stress sigma. So what we can do, second thing, to mostly the manufacturers, and they have focused on this, protecting the glass surface against the generation of large flaws to avoid the fracture. So the technological advantage has taken place with this fundamental understanding that if we protect the glass surface against the generation large flaws to avoid the fracture. So what we can do, we can protect the glass surface from the severe cracks by preserving the pristine surfaces. Pristine means when the glass is made, so it has not come in the contact with the other material. So the glass is free from the flaw. As soon as it starts having contact with the other surfaces, the flaws start developing. So one thing is that we can do protect this glass surface. So how we can do fire polishing, let it be hard, and anti-friction coating. So the friction coefficient becomes small, and when the friction coefficient becomes small, then again the flaw generation of the glass is small. So that is the first step one can do. The second, the development came that suppose we go with this that a crack on the surface. What we can see that if the article is under tension, the crack will open up like a simple page, a simple piece of paper. If you have a just cut on some point, and if you stretch it, it will tear off with very small force. But if it is not a cut at any point, it will not tear off. And so here also the glass is under tension, the glass is easy to fail. But if you have the compression, the flaws will be closing up. So here the glass will not fail. So what we can do that opening up the crack can be restricted if we can make the glass surface under compression. So that is the most important aspect of toughening of the glass. So this is the fundamental answer that first is natural strength, we can protect the natural strength. Second is that if we have this surface under compression, so what we have to do whenever some stresses are developed, so initially some load is used to work against the compression, and until unless this load is more than the compressive stress, the glass will not fail. So glasses with surface under compression are known as the toughened glass, and we are using in large places the toughened glass. Now, the toughening, again technology has developed for making the toughening of the glass. There are two types of toughening: thermal toughening, that is quench hardening, and another is chemical toughening. And we can learn in very simple manner. Technologically operating, it may be difficult, but it is very simple to learn. Whatever glass, first the glass article is made in the regular, whatever shape and size we know we want to have, then glass is heated up to a temperature above strain point. The strain point is very important, that at above strain point, whatever stresses are there, they are relieved by themselves. So when glass is heated above, the whole article is heated above strain point, then only the surfaces are rapidly quenched by steam of air. While the interior of the glass cools later, it is not. It cools slowly. So what will happen? The surface will shrink, but they will produce stress on the inner layer. Those stresses will be relieved because the glass is at above the strain point. Now we cool from the strain point. What will happen? Inner glass is hot, outer glass is cool. So inner glass will cool down, and during cooling down, it will shrink. When it will shrink, the layers, the outer layer, inner layer, they are intact. So what it will do? It will produce compressive stresses on the surface layer of the glass. When the surface layers are compressed, they restrict the growth of the crack. So this is the fundamental for the making the thermally toughened glass. But mostly the thermally toughened glass, they are we can make with only flat glass. The second thing is that because they are under compression, so large amount of strain energy is stored in the glass. So when the large amount of energy is stored in the glass, whenever they will break in a small fragment. Now, so you can think of a running car. If it breaks in the large fragments, because of the momentum, they can harm more. If the fragment is a smaller size, their momentum is smaller, so they will less dangerous. And second thing is that this interlayer by polymer interlayer PVB, this we can again that even though the glass fails in the small fragments, the shape of the article remains intact. So that also make a safety glass. Those main safety glass for automobile, it has developed on the basis that we have the thermally toughened glass, and with the help of interlayer, so even if it breaks, the small pieces of glass will not fly off and they will not have an injury to the glass. For the other type of article like bottles and other things, for other application, we want to have this strengthening, we have to make use of chemical toughening. Again, in chemical toughening, it is a simple principle that small size ions are to be replaced with the larger size ion. So when the larger size ions are impregnated by the ion exchange, then the layer becomes compressive and the strength of that glass is higher. The second is that surface crystallization means that if we have the crystallized in the surface with the some crystals, minute crystals of nano size, etc., then again it will have the high strength. So this is the first step that we have to work. The technology has developed, and mostly we are using this kind of technology. The second question comes that do the articles fail after installation without any or unknown reason? Recently, people may know that who are in the field that a Chennai airport, many glass panels, they have shattered. In different airports, we are using large number of glasses, and suddenly what happens that they are operating safely and lightly, and suddenly they fail. Sometimes some injury may come if some passengers are around. If passengers are not around, they save. So the glass articles, they fail unknowingly. What may happen? Initially, it is tested that they are having sufficient strength, but what will happen? Again, the question came that whether the Griffith theory that particular flaw size is less than the critical size, it is not failing. More than the critical size, it is failing. So what happening in the delayed failing? So it came into that in some environment, the subcritical flaws, they can grow under the application of stress. So what will happen that it is a kind of delayed fracture. And when this application is necessary, these delayed fracture is to be worked out in some strategic application, like in aeroplanes, spaceship, submarine, some other places where the breakage of the glass article, the environment, we are protected, we are in the capsule of against the environment, and that is hazardous. So what we can do that, if we understand the delayed fracture, we can say that we can predict the lifetime. So if we understand the subcritical growth of the crack within the glass, what we can show that we can find out that how we can predict the life of the glass. And once we can predict the life of the glass article, what we can do, we can replace the glass article before it fails. And again, it can protect this. So again, what has been done, that various experimental investigation have been done, that what happens when the crack velocity, the subcritical crack velocity under different environment. And what has been found that it depends on the stress intensity factor, the velocity of the crack, it depends on the environment, it depends on the temperature, and it depends on the pH. So most the water present in the atmosphere is because the silica and they react with the atmosphere, there's some stress corrosion, and because of that stress corrosion, the cracks open up. So once we know this, that due to stress corrosion, the crack will be opening out. So what again we can do some basic mathematics, that how the cracks will velocity is dependent on the stress intensity factor. So we can see the third, that crack velocity is greater for greater value of relative humidity, increases with increasing the pH for the silica in the glass, pH for the silica in the glass water, it is higher for higher temperature. So the humidity, temperature, and the stress intensity factor, they are responsible for the delayed fracture. And we can calculate this. So here their explanation. So we have to tackle the problem of delayed fracture. So the solution is that prediction of the life cycle and recommendation of replacement of article even if it is not failed, and that will give this safety to safety of the glass. So what we can do, that one can have a calculation by first principle, and the equation in the bracket, that is important, that this time of failure. So what we can do, we can have an estimation of time of failure for the glass, and that is having the different parameters, Young modulus, this sigma I and K1C. So the inert or initial strength sigma I, that is very important, that in humidity-free environment, what is the strength of the glass? If we know that is strength of glass, and the K1C, the critical stress intensity factor. So under service stress sigma, we can find out what is the failure. So, but these parameters are difficult to determine. So there is another method that we do the proof testing. Proof testing means that initially, suppose service stress is some 200 megapascal. So what we can do, we can have a glass article tested to higher load, 2 times or 3 times higher load. And if it does not fail, then we can say we can calculate that, okay, the glass article will not fail till that time. So here in proof testing, we have to estimate what should be the factor of multiplication for the proof testing stress. So there the proof test stress is applied to each specimen for any time. So from there, we can estimate what is the initial critical size of the flaw which is present, that is, so the proof test stress. So here again with the equation, what we can do, that we can find out the minimum time of failure. It may failure may occur, but we can have that the minimum time of failure, and the factor is sigma p upon sigma s. Sigma s is the service stress and sigma p is the. So here what we have found that from the graph we can have stress and time of failure, and we can have from this graph we can find out, suppose we want to have a stress of 100 megapascals, and so here, so we want to have, suppose want to safe life of 10 power 6. So from this graph we can find out that if we have the proof testing 4 times that the service stress, we can have the whatever, if the article survive with the proof stress, the article will survive minimum that period of time. So for the strategic applications, we can do this proof testing. So this technology is not being utilized. So this thing that what we do, that suppose different applications, we have to design the glass, designing with the glass. What we can do, failure stress sensitive to flaw size, their distribution. So consider variability. But still with the considered variability, we can have a design of the glass. So what is the service stress, what is the shape, size, and other things on the glass, and how the different flaws may occur. With this, we can have the survival probability, and with which we can make a more safe glass with more safety. In summary, this is my summary of my presentation, that there is good hope that if we think some out of box and postulate to understand the material world and in integrated and fundamental basics. So what we can come out with the solution, they may be theoretical, look like theoretical first, but they can be testified that they are good enough to describe the behavior, and on the basis of those concepts, those understanding, we can make the development of technology and with innovative designs. And then what we can do, that in that whatever technology is developed, the technology is to be used by industry. So, and then we can make the standardization process. So what is the basic characteristic? Standard process means that what is the basic characteristic. So under those characteristics, they may be tested in standard way. If the articles are surviving, they are safe to use. If the articles are not surviving, they are not safe to use. So for the society development, the role of scientists, technologists, industrialists, and standard organization is there to have a product to be used with safe purpose. So this is my thank you.
Thank you so much, sir, for such an in-depth knowledge, for sharing such an in-depth knowledge with us. Whatever question we get from the attendees, we'll share the questions with you separately.
Okay, thank you.
Thank you. We have 2 more presentations after lunch and one interesting technical poll at the end of the session today. We will have a lunch break of 30 minutes now and we will resume at 2 o'clock.
International Center for Automotive Technology, ICAT. The most populous democracy in the world, the Republic of India is a vast South Asian country with diverse terrain ranging from the Himalayan peaks to Indian Ocean coastline and a history dating back 5 millennia. A cultural melting pot, it is a pluralistic, multilingual and multi-ethnic society which became one of the fastest growing major economies post market-based economic reforms in 1991. A key contributor to this enviable position is the automotive industry, which accounts for 7.1% of the country's gross domestic product, GDP. Located at the northern hub of automotive industry in Manesar, Haryana, ICAT has emerged as a comprehensive technical partner to the automotive industry and renders valuable services such as homologation and certification, developmental projects and testing and automotive R&D projects. The state-of-the-art infrastructure at ICAT is pivotal in carrying out these functions and can be broadly classified into following areas of excellence. Powertrain Laboratory. Powertrain Lab offers services in the fields of vehicle and engine emission and performance test, along with calibration services. The labs are fully equipped to undertake the homologation test of both the engine and the vehicle as per latest Indian, European and other international regulations of automobiles. Apart from homologation, performance measurement of engine and vehicle, fuel consumption measurement and optimization, emission tests and optimization including EGR, engine mapping, exhaust temperature optimization and ECU calibration of vehicles. Engine Test Cell, ETC. There are 13 transient test cells ranging from 35 kilowatt to 880 kilowatt capacity. These engine test cells are capable of carrying out advanced tests such as performance, optimization, emissions measurements, EGR and SCR optimization, durability and validation for engines for various automotive and no automotive applications. Vehicle Test Cell, VTC. There are 6 emissions vehicle chassis dynamometers and 3 mileage chassis dynamometers capable of testing vehicles up to 5,000 kg GVW. Each test cell is equipped to test and check various emission parameters such as hydrocarbon, carbon monoxide, carbon dioxide, nitrogen oxides and particulates as per BS6 and Euro 6 norms and durability and validation. The lab is also equipped for an on-road emission performance. Vehicle Evaluation Lab, VEL. Vehicle Evaluation Lab undertakes key tests including coast down, brake performance, maximum speed, fuel consumption, acceleration and performance, drivability trials, tire noise testing, endurance and durability tests, ABS test, etc., as per the specific needs of the customer on test tracks. Component Certification Lab, CCL. Component Certification Lab CCL provides services related to certification and homologation of automotive components. As per Central Motor Vehicle Rules, CMVR, the lab undertakes developmental testing, environmental testing, vibration testing, hot and cold chamber, weatherometer, ozone chamber, salt spray chamber, walk-in chamber, etc. for all components for on-road and off-road vehicles. Photometry Lab. Photometry Lab at ICAT is the state-of-the-art facility and one of the finest in the world. Fundamental research is carried out on LED measurement methods, spectroradiometric measurements techniques, visibility and glare, headlamp aiming, conspicuity, telematics, etc. Not only does the lab cater to automotive lighting, but also provides testing and development services to non-automotive applications, which includes domestic lighting and aviation lighting. Materials Lab. Multiple facilities available here in Materials Lab include mechanical testing of rubbers and plastics, coolant test facility, chemical testing of polymers, flammability testing of upholstery, carpet materials, as well as inner components, wiring harness for kits used in automotive 2, 3 and 4-wheelers, etc. Fatigue Lab. In order to ascertain the life of products, extensive tests are undertaken by OEMs and their vendors. These tests include durability and integrity assessment of vehicles, systems and subsystems under various driving and environmental conditions. Fatigue Lab in ICAT has state-of-the-art facility wherein you can bring in roads to the lab evaluation, multi-axis simulation tables, exposters and various actuators in various simulated environmental conditions make this possible. Electromagnetic Compatibility Lab, EMC. The application of electronics has significantly increased in automobiles over last few decades. In view of this, the electromagnetic compatibility compliance has become of paramount importance both at the device as well as vehicle level. Passive Safety Lab simulates various crash scenarios. This is to ensure occupant and pedestrian protection in the event when a vehicle encounters a crash and the ability of the vehicle structure to absorb the energy of the impact. Some of the services offered are frontal impact crash test, side impact crash test, side pole impact, rear impact test, static rollover, pedestrian protection testing, etc. A notable point is that ICAT was the first organization to set up pedestrian safety lab in India. Tire Test Lab. Tire, being crucial for the road safety, comfort and fuel economy of the vehicle, needs to undergo a comprehensive and rigorous testing to evaluate and ensure its adequate performance. Both performance and rolling resistance evaluation of tires for various category of vehicles is undertaken in this lab. Noise, Vibration and Harshness Lab. A Center of Excellence on Noise, Vibration and Harshness, NVH, is the first of its kind of facility in India to offer services for development of vehicles and components, testing and validation. The lab is equipped with the semi-anechoic chambers with chassis dynamometers and state-of-the-art equipment and instrumentation. Automotive Electronics and Electrical Lab. The AEEL at ICAT is one of the most important labs considering the rapid increase in the use of electrical and electronics in the vehicles. The major facilities available at AEEL are related to electrical measurements, ECU validation, environmental testing, altitude testing, dust and water ingress testing, thermal shock, vibration and shock testing, weather resistance, battery cyclers and motor test benches, etc. CAD-CAE Lab. CAD-CAE Lab helps in design and development of vehicle and its component. Here, components and vehicles are not only tested virtually, but also studied for modification and optimization if required. Apart from virtual testing, it offers other services such as CAD modeling, drawings, fixtures and structure design. ICAT is poised to develop into Automotive Development Center, not only to provide certification services, but also product development services to Indian and global OEMs. At ICAT, we constantly strive for excellence, both in terms of building facilities and building matching skills. International Center for Automotive Technology, ICAT. International Center for Automotive Technology, ICAT. The most populous democracy in the world, the Republic of India is a vast South Asian country with diverse terrain ranging from the Himalayan peaks to Indian Ocean coastline and a history dating back 5 millennia. A cultural melting pot, it is a pluralistic, multilingual and multi-ethnic society, which became one of the fastest growing major economies post-market-based economic reforms in 1991. A key contributor to this enviable position is the automotive industry, which accounts for 7.1% of the country's gross domestic product, GDP. Located at the northern hub of automotive industry in Manesar, Haryana, ICAT has emerged as a comprehensive technical partner to the automotive industry and renders valuable services such as homologation and certification, developmental projects and testing and automotive R&D projects. The state-of-the-art infrastructure at ICAT is pivotal in carrying out these functions and can be broadly classified into following areas of excellence. Powertrain Laboratory. Powertrain Lab offers services in the fields of vehicle and engine emission and performance test, along with calibration services. The labs are fully equipped to undertake the homologation test of both the engine and the vehicle as per latest Indian, European and other international regulations of automobiles. Apart from homologation, performance measurement of engine and vehicle, fuel consumption measurement and optimization, emission tests and optimization including EGR, engine mapping, exhaust temperature optimization and ECU calibration of vehicles. Engine Test Cell, ETC. There are 13 transient test cells ranging from 35 kilowatt to 880 kilowatt capacity. These engine test cells are capable of carrying out advanced tests such as performance, optimization, emissions measurements, EGR and SCR optimization, durability and validation for engines for various automotive and no automotive applications. Vehicle Test Cell, VTC. There are 6 emissions vehicle chassis dynamometers and 3 mileage chassis dynamometers capable of testing vehicles up to 5,000 kg GVW. Each test cell is equipped to test and check various emission parameters such as hydrocarbon, carbon monoxide, carbon dioxide, nitrogen oxides and particulates as per BS6 and Euro 6 norms and durability and validation. The lab is also equipped for an on-road emission performance. Vehicle Evaluation Lab, VEL. Vehicle Evaluation Lab undertakes key tests including coast down, brake performance, maximum speed, fuel consumption, acceleration and performance, drivability trials, tire noise testing, endurance and durability tests, ABS test, etc., as per the specific needs of the customer on test tracks. Component Certification Lab, CCL. Component Certification Lab CCL provides services related to certification and homologation of automotive components. As per Central Motor Vehicle Rules, CMVR, the lab undertakes developmental testing, environmental testing, vibration testing, hot and cold chamber, weatherometer, ozone chamber, salt spray chamber, walk-in chamber, etc. for all components for on-road and off-road vehicles. Photometry Lab. Photometry Lab at ICAT is the state-of-the-art facility and one of the finest in the world. Fundamental research is carried out on LED measurement methods, spectroradiometric measurements techniques, visibility and glare, headlamp aiming, conspicuity, telematics, etc. Not only does the lab cater to automotive lighting, but also provides testing and development services to non-automotive applications, which includes domestic lighting and aviation lighting. Materials Lab. Multiple facilities available here in Materials Lab include mechanical testing of rubbers and plastics, coolant test facility, chemical testing of polymers, flammability testing of upholstery, carpet materials, as well as inner components, wiring harness for kits used in automotive 2, 3 and 4-wheelers, etc. Fatigue Lab. In order to ascertain the life of products, extensive tests are undertaken by OEMs and their vendors. These tests include durability and integrity assessment of vehicles, systems and subsystems under various driving and environmental conditions. Fatigue Lab in ICAT has state-of-the-art facility wherein you can bring in roads to the lab evaluation, multi-axis simulation tables, X-posters and various actuators in various simulated environmental conditions make this possible. Electromagnetic Compatibility Lab, EMC. The application of electronics has significantly increased in automobiles over last few decades. In view of this, the electromagnetic compatibility compliance has become of paramount importance both at the device as well as vehicle level. Passive Safety Lab simulates various crash scenarios. This is to ensure occupant and pedestrian protection in the event when a vehicle encounters a crash and the ability of the vehicle structure to absorb the energy of the impact. Some of the services offered are frontal impact crash test, side impact crash test, side pole impact, rear impact test, static rollover, pedestrian protection testing, etc. A notable point is that ICAT was the first organization to set up pedestrian safety lab in India. Tire Test Lab. Tire, being crucial for the road safety, comfort and fuel economy of the vehicle, needs to undergo a comprehensive and rigorous testing to evaluate and ensure its adequate performance. Both performance and rolling resistance evaluation of tires for various category of vehicles is undertaken in this lab. Noise, Vibration and Harshness Lab. A Center of Excellence on Noise, Vibration and Harshness, NVH, is the first of its kind of facility in India to offer services for development of vehicles and components, testing and validation. The lab is equipped with the semi-anechoic chambers with chassis dynamometers and state-of-the-art equipment and instrumentation. Automotive Electronics and Electrical Lab. The AEEL at ICAT is one of the most important labs considering the rapid increase in the use of electrical and electronics in the vehicles. The major facilities available at AEEL are related to electrical measurements, ECU validation, environmental testing, altitude testing, dust and water ingress testing, thermal shock, vibration and shock testing, weather resistance, battery cyclers and motor test benches, etc. CAD-CAE Lab. CAD-CAE Lab helps in design and development of vehicle and its component. Here, components and vehicles are not only tested virtually, but also studied for modification and optimization if required. Apart from virtual testing, it offers other services such as CAD modeling, drawings, fixtures and structure design. ICAT is poised to develop into Automotive Development Center, not only to provide certification services, but also product development services to Indian and global OEMs. At ICAT, we constantly strive for excellence, both in terms of building facilities and building matching skills. International Center for Automotive Technology, ICAT. International Center for Automotive Technology, ICAT. The most populous democracy in the world, the Republic of India is a vast South Asian country with diverse terrain ranging from the Himalayan peaks to Indian Ocean coastline and a history dating back 5 millennia. A cultural melting pot, it is a pluralistic, multilingual and multi-ethnic society, which became one of the fastest growing major economies post-market-based economic reforms in 1991. A key contributor to this enviable position is the automotive industry, which accounts for 7.1% of the country's gross domestic product, GDP. Located at the northern hub of automotive industry in Manesar, Haryana, ICAT has emerged as a comprehensive technical partner to the automotive industry and renders valuable services such as homologation and certification, developmental projects and testing and automotive R&D projects. The state-of-the-art infrastructure at ICAT is pivotal in carrying out these functions and can be broadly classified into following areas of excellence. Powertrain Laboratory. Powertrain Lab offers services in the fields of vehicle and engine emission and performance test, along with calibration services. The labs are fully equipped to undertake the homologation test of both the engine and the vehicle as per latest Indian, European and other international regulations of automobiles. Apart from homologation, performance measurement of engine and vehicle, fuel consumption measurement and optimization, emission tests and optimization including EGR, engine mapping, exhaust temperature optimization and ECU calibration of vehicles. Engine Test Cell, ETC. There are 13 transient test cells ranging from 35 kilowatt to 880 kilowatt capacity. These engine test cells are capable of carrying out advanced tests such as performance, optimization, emissions measurements, EGR and SCR optimization, durability and validation for engines for various automotive and no automotive applications. Vehicle Test Cell, VTC. There are 6 emissions vehicle chassis dynamometers and 3 mileage chassis dynamometers capable of testing vehicles up to 5,000 kg GVW. Each test cell is equipped to test and check various emission parameters such as hydrocarbon, carbon monoxide, carbon dioxide, nitrogen oxides and particulates as per BS6 and Euro 6 norms and durability and validation. The lab is also equipped for an on-road emission performance. Vehicle Evaluation Lab, VEL. Vehicle Evaluation Lab undertakes key tests including coast down, brake performance, maximum speed, fuel consumption, acceleration and performance, drivability trials, tire noise testing, endurance and durability tests, ABS test, etc., as per the specific needs of the customer on test tracks. Component Certification Lab, CCL. Component Certification Lab, CCL, provides services related to certification and homologation of automotive components. As per Central Motor Vehicle Rules, CMVR, the lab undertakes developmental testing, environmental testing, vibration testing, hot and cold chamber, weatherometer, ozone chamber, salt spray chamber, walk-in chamber, etc. for all components for on-road and off-road vehicles. Photometry Lab. Photometry Lab at ICAT is the state-of-the-art facility and one of the finest in the world. Fundamental research is carried out on LED measurement methods, spectroradiometric measurements techniques, visibility and glare, headlamp aiming, conspicuity, telematics, etc. Not only does the lab cater to automotive lighting, but also provides testing and development services to non-automotive applications, which includes domestic lighting and aviation lighting. Materials Lab. Multiple facilities available here in Materials Lab include mechanical testing of rubbers and plastics, coolant test facility, chemical testing of polymers, flammability testing of upholstery, carpet materials, as well as inner components, wiring harness for kits used in automotive 2, 3 and 4-wheelers, etc. Fatigue Lab. In order to ascertain the life of products, extensive tests are undertaken by OEMs and their vendors. These tests include durability and integrity assessment of vehicles, systems and subsystems under various driving and environmental conditions. Fatigue Lab in ICAT has state-of-the-art facility wherein you can bring in road to the lab evaluation, multi-axis simulation tables, X-posters and various actuators in various simulated environmental conditions make this possible. Electromagnetic Compatibility Lab, EMC. The application of electronics has significantly increased in automobiles over last few decades. In view of this, the electromagnetic compatibility compliance has become of paramount importance both at the device as well as vehicle level. Passive Safety Lab simulates various crash scenarios. This is to ensure occupant and pedestrian protection in the event when a vehicle encounters a crash and the ability of the vehicle structure to absorb the energy of the impact. Some of the services offered are frontal impact crash test, side impact crash test, side pole impact, rear impact test, static rollover, pedestrian protection testing, etc. A notable point is that ICAT was the first organization to set up pedestrian safety lab in India. Tire Test Lab. Tire, being crucial for the road safety, comfort and fuel economy of the vehicle, needs to undergo a comprehensive and rigorous testing to evaluate and ensure its adequate performance. Both performance and rolling resistance evaluation of tires for various category of vehicles is undertaken in this lab. Noise, Vibration and Harshness Lab. A Center of Excellence on Noise, Vibration and Harshness, NVH, is the first of its kind of facility in India to offer services for development of vehicles and components, testing and validation. The lab is equipped with the semi-anechoic chambers with chassis dynamometers and state-of-the-art equipment and instrumentation. Automotive Electronics and Electrical Lab. The AEEL at ICAT is one of the most important labs considering the rapid increase in the use of electrical and electronics in the vehicles. The major facilities available at AEEL are related to electrical measurements, ECU validation, environmental testing, altitude testing, dust and water ingress testing, thermal shock, vibration and shock testing, weather resistance, battery cyclers and motor test benches, etc. CAD-CAE Lab. CAD-CAE Lab helps in design and development of vehicle and its component. Here, components and vehicles are not only tested virtually, but also studied for modification and optimization if required. Apart from virtual testing, it offers other services such as CAD modeling, drawings, fixtures and structure design. ICAT is poised to develop into Automotive Development Center, not only to provide certification services, but also product development services to Indian and global OEMs. At ICAT, we constantly strive for excellence, both in terms of building facilities and building matching skills. International Center for Automotive Technology, ICAT. International Center for Automotive Technology, ICAT. The most populous democracy in the world, the Republic of India is a vast South Asian country with diverse terrain ranging from the Himalayan peaks to Indian Ocean coastline and a history dating back 5 millennia. A cultural melting pot, it is a pluralistic, multilingual and multi-ethnic society, which became one of the fastest growing major economies post-market-based economic reforms in 1991. A key contributor to this enviable position is the automotive industry, which accounts for 7.1% of the country's gross domestic product, GDP. Located at the northern hub of automotive industry in Manesar, Haryana, ICAT has emerged as a comprehensive technical partner to the automotive industry and renders valuable services such as homologation and certification, developmental projects and testing and automotive R&D projects. The state-of-the-art infrastructure at ICAT is pivotal in carrying out these functions and can be broadly classified into following areas of excellence. Powertrain Laboratory. Powertrain Lab offers services in the fields of vehicle and engine emission and performance test, along with calibration services. The labs are fully equipped to undertake the homologation test of both the engine and the vehicle as per latest Indian, European and other international regulations of automobiles. Apart from homologation, performance measurement of engine and vehicle, fuel consumption measurement and optimization, emission tests and optimization including EGR, engine mapping, exhaust temperature optimization and ECU calibration of vehicles. Engine Test Cell, ETC. There are 13 transient test cells ranging from 35 kilowatt to 880 kilowatt capacity. These engine test cells are capable of carrying out advanced tests such as performance, optimization, emissions measurements, EGR and SCR optimization, durability and validation for engines for various automotive and no automotive applications. Vehicle Test Cell, VTC. There are 6 emissions vehicle chassis dynamometers and 3 mileage chassis dynamometers capable of testing vehicles up to 5,000 kg GVW. Each test cell is equipped to test and check various emission parameters such as hydrocarbon, carbon monoxide, carbon dioxide, nitrogen oxides and particulates as per BS6 and Euro 6 norms and durability and validation. The lab is also equipped for an on-road emission performance. Vehicle Evaluation Lab, VEL. Vehicle Evaluation Lab undertakes key tests including coast down, brake performance, maximum speed, fuel consumption, acceleration and performance, drivability trials, tire noise testing, endurance and durability tests, ABS test, etc., as per the specific needs of the customer on test tracks. Component Certification Lab, CCL. Component Certification Lab CCL provides services related to certification and homologation of automotive components. As per Central Motor Vehicle Rules, CMVR, the lab undertakes developmental testing, environmental testing, vibration testing, hot and cold chamber, weatherometer, ozone chamber, salt spray chamber, walk-in chamber, etc. for all components for on-road and off-road vehicles. Photometry Lab. Photometry Lab at ICAT is the state-of-the-art facility and one of the finest in the world. Fundamental research is carried out on LED measurement methods, spectroradiometric measurements techniques, visibility and glare, headlamp aiming, conspicuity, telematics, etc. Not only does the lab cater to automotive lighting, but also provides testing and development services to non-automotive applications, which includes domestic lighting and aviation lighting. Materials Lab. Multiple facilities available here in Materials Lab include mechanical testing of rubbers and plastics, coolant test facility, chemical testing of polymers, flammability testing of upholstery, carpet materials, as well as inner components, wiring harness for kits used in automotive 2, 3 and 4-wheelers, etc. Fatigue Lab. In order to ascertain the life of products, extensive tests are undertaken by OEMs and their vendors. These tests include durability and integrity assessment of vehicles, systems and subsystems under various driving and environmental conditions. Fatigue Lab in ICAT has state-of-the-art facility wherein you can bring in road to the lab evaluation, multi-axis simulation tables, X-posters and various actuators in various simulated environmental conditions make this possible. Electromagnetic Compatibility Lab, EMC. The application of electronics has significantly increased in automobiles over last few decades. In view of this, the electromagnetic compatibility compliance has become of paramount importance both at the device as well as vehicle level. Passive Safety Lab simulates various crash scenarios. This is to ensure occupant and pedestrian protection in the event when a vehicle encounters a crash and the ability of the vehicle's
Welcome back, ladies and gentlemen. We will now proceed further for the third and last technical session of the day, which includes 2 technical presentations. For the first technical session, I would like to introduce our first speaker, Shri Ravi Balakrishnan. Shri Ravi Balakrishnan is a mechanical engineer from REC, Calicut. He started his career with Murugappa Group before moving on to Saint Gobain Group in 1996. Over the past 25 years, he handled various roles and responsibilities within group in project management, product development, and global sourcing. From 2016 onwards, he has been handling sales, marketing, and project function in Securit Group. Operating out of Chennai, he is a part of Securit India leadership team, driving growth and innovation. His interest includes new technologies in electric vehicles. Thank you for joining us today, sir. I would now request Shri Ravi Balakrishnan to start with their presentation.
So good afternoon to all. Am I audible and could you see my screen?
Yes, sir, you are audible and we can see the presentation as well.
Thank you. So first of all, thanks to ICAT for giving me this opportunity, and welcome to all the participants from the academia and OEM side. I would like to touch upon some of the aspects of the future technologies on automotive glazing. But before that, let us just put things in the context. The automotive industry is going through a major disruption with what we call as the case, which is connected, autonomous, and shared, and electric mobility. Depending upon which part of the geography you are in, which part of the world you are in, some of them would have advanced much more, especially in some parts of Europe. In US, you have much more electric already. Before the pandemic, India was really moving ahead in a much big way in shared mobility and things like that. So when the whole industry is going through such a big change, how does the glazing industry and glazing technology adapt to these changes, and how does it come up with new solutions which are needed to make every journey a pleasurable one? So I am here, the objective is really not to cover everything. I'm not trying to be really comprehensive, but to show you some of the flavors in few, I would say, few buckets of technological aspects where we are looking at how could we have comfort. So there are topics under thermal comfort, acoustic comfort, visual comfort, etc. So for example, when we speak about electrical vehicles, you think that there is no IC engine and it doesn't make any noise, so probably acoustic is not important. But contrary to what you initially think, in an EV, when the IC engine doesn't make any noise, the importance of even better acoustics is every small noise gets amplified, and even better acoustics is needed inside the cabin, so it becomes even more important. Visual comfort, how do you increase the visual comfort and provide information to the driver? Then we have another basket where we can look at designs, where how do you improve the aesthetics of a car with complex designs, and how do you give freedom to the designer to come up with what is typically difficult to achieve with glazing. So we can look at polymer glazings there. We can also bring in some lighting and all those things to bring the glazing a bit more active and participate in the mood of the car inside. Then we have the most interesting part, which is the embedded technologies, where we are talking about smart windshields, and in a connected world, how do you connect through the glazing? So this is broadly what I would like to talk about. Moving forward, about thermal comfort, I think previous speaker also touched upon that. So here on your screen, you see glazing where what we call as the, in our language, Sangama Clima coat. Here, what we are doing is, in a laminated windshield, one of the glass gets coated, typically a silver coating. So silver is a metallic coating, and it's also a conductor of electricity. So it passes through normally magneton sputtering, and you have a nano layer of silver deposited on one face of the glass. Now, once you sandwich it, what happens is, when you park the car in a hot sun, a big part of the sunlight, which is bringing in heat. So the solar spectrum contains visible light, but it also contains UV, and on the other side, it also contains infrared, which brings in a lot of heat. So you can selectively cut the infrared part of it and only bring in the light. Mind you, this is a windshield, so you cannot bring down the light transmission because you need 70% light transmission. Now, so you have, with this coating, you are achieving a strong amount of reflection of the heat alone and bringing only the cool light inside. So visibility is good, it is comfortable. Now the added advantage is, because this is a conductive coating, you could put in two bus bars at the top and bottom and pass on the bit of electricity from your car battery, and it starts heating. So what is the application? In a winter, when you want to do defrosting of your windshield, you don't have to struggle with that. With a push of a button, this windshield can also get heated up with the conductive coating emitting heat, and you have a defrosting within minutes. So it is useful in summer to cut down the heat, and it is again useful during winter to defrost your windshield. So this is one of the interesting products. Moving on, coming to again acoustic comfort. So here what we do is, again, on a laminated product, you, instead of using a normal PVB, you put a acoustic PVB. Acoustic PVB has got 3 layers. Acoustic dampening layer sandwiched between 2 normal layers. So this is roughly 0.8 millimeter thick. And when you do this, you get good acoustic properties. At the bottom, at the right side of the slide, you see that what kind of noises it can typically cut. Again, in a very noisy environment in India, like honking, it won't be of, it cannot cut the horn noises, but it can really cut down tire noises, wind noises, engine noises, etc. At around 3000 hertz, it has got a very good efficiency. And in a very Indian context, it's not only limited to cars, it can be also for commercial vehicles. Typically, in a commercial vehicle, the driver is continuously driving the big truck for 8 hours or even more, and he is practically sitting on the engine, which is constantly a large diesel engine, which is constantly producing noise. So we have found that acoustic PVB could even cut those noises and make the cabins quieter, allowing it for better articulation index, which in simply put allows you to have a conversation or listen to music in a better way. So another area where things are moving forward is acoustic comfort. We have different generations of acoustic PVB. From Gen 1, we have moved to Gen 2, which has even better performance, and studies are going on how to improve it even further. Okay, the another interesting product here is a sunroof. So similar to what I showed earlier, here in the sunroof, we could insert a PDLC film between the 2 glasses. PDLC stands for polymer dispersed liquid crystal. Here what you do is the sunroof is a fixed sunroof directly mounted onto the roof of the car, thus eliminating cumbersome mechanisms and some noises associated with movement of the mechanism and all those things. It also reduces the headroom requirement for the car maker, so you don't need to accommodate the aluminum frame and all those things associated with the movement. Now, the purpose of the sunroof is sometimes you want to have privacy and you want it to be dark, and sometimes you want to see the sky above you. How do you do that? With a simple switch of a button. So with the PDLC, you have full control over to how to make it opaque or transparent. So this has a small power supply and a control unit, and with the push of a button, you could make it either a visible one or an opaque one. So gives you both thermal comfort and visual comfort. Added to that, you have acoustic comfort, and for the designer, there is a more headroom to play with. Further, moving on, another interesting development which is happening. I think many of you know that you would have seen in movies and things like that. In a fighter aeroplane, you see a green target acquisition, on the windshield of a fighter pilot. From that technology, now it has reached into the cars, which is called heads-up display. Essentially, it means the essential informations, what is needed by the driver, he has it directly on the windshield by keeping his head up. He doesn't have to look down onto the dashboard to see certain information. What kind of information can be projected? Any information which is available with the car's system can be taken up and projected onto the windscreen. Here, the technology is you have a projector which is projecting onto the windshield. The windshield is specially designed HUD windshield, which has got a special characteristic and a tapered polyvinyl butyral layer in between, which avoids ghosting. So with this windshield, you have a very clear image in front of you, probably helping you with vital statistics like speed, helping you with navigation, probably outside temperatures, inside temperature, whatever information you want can come up on your screen. Earlier designs had very small area because of the design constraints. The heads-up display was quite small. Today, thanks to augmented reality HUDs, we have larger and larger heads-up displays, and you could also have depth perception on the heads-up display, which means you will see an arrow at the place where you have to take a turn and not on your windshield. You will see it at a depth where actually you get the with the help of augmented reality, you get also the depth perception. Now here is the interesting thing. HUD had existed for a long time, but it was very much limited to premium vehicles. Thanks to the adaptation of the technology and cost coming down, now this has started coming into the mid-segment variants, and shortly you will start this technology becoming more and more popular as the cost starts coming down. So OEM, the glass maker, and the projector maker has to start working right from the concept stage to realize a good heads-up display in the car. So this is another area where there are rapid progresses happening, and many more options of displays and integration with entertainment system, navigation system is also happening. Moving on, the next topic is about design and how do you give more design freedom to the car designer. So here, the glass, when you try to bend, there are limitations up to what level you can achieve complex shapes. So in certain cases, it is advantageous to go for polymer glazing. So here you have typically in a quarter glass, which is behind the rear window, a complex shape which could be hugging the car body or integrating almost very closely with the backlight. There you could use a polymer glazing, and polymer glazing is significantly lighter and it allows you to mold many things and complex shapes. So you could also have additional components built into it. And there are cases where people have integrated LEDs also into the polymer glazing. So you could have some certain lighting components also attached to it. It has got high impact resistance. So it has qualified and it's being now more and more being used in European market. And the recent regulations in India is also moving towards allowing polymer glazing in the Indian market also. So now it is up to the car maker and the glass maker to work together and look at these opportunities also. So this gives a lot of design freedom, integration of components, integration of electronics into the small component, which is typically behind the back glass. Another aspect of design, which is catching up quite quickly and very interesting for the passenger who's sitting inside the car, you could have lighting in glazing. Again, very similar to the technology of laminating the PDLC film, you could also have certain light emitting components embedded inside the glass. Now, this brings in lighting into the car. Now, it could be just an ambient lighting or a mood lighting, as you call it, giving you different kinds of lighting depending upon a switch of a button. You could change that. Or you want higher intensity lighting, you could have concentrated LEDs and bring in, for example, a lighting for reading purpose inside the car. So this can be integrated into a large sunroof, and prototypes are already being tested and validated in advanced stages with lighting in glazing. Now, this could be just, like I said, a mood lighting or a design element. Somebody wants to see stars in the night when you look up. So you could have stars on your sunroof. Or it could be, like I said, just a soothing color with a blue or a red or a green. So different kinds of designs, colors, and light intensity is possible. And this can be integrated into the sunroof and also possibly into some parts of your windshield to indicate certain things. So lighting in glazing is making rapid progresses, and this is also bringing a lot of design freedom to enhance the customer experience inside the vehicle. Now, again, the glass is the interface from inside to outside. So while I speak about inside, why not outside? So again, some of the lighting in the glazing can be used to display things outside the vehicle also. So that is another possibility. So next, in terms of technology, the interesting things where multiple options are emerging is embedded technology. So we already saw that you could have a acoustic PVB which could reduce the noise. You could put a PDLC which could make it opaque or transparent. You also saw about LED which could emit light. So what are the other possibilities? So there are now almost everything is a touch device, whether it's your phone, the latest laptop screens are touchable. So everybody is so familiar with touch. Can we bring in the touch control onto the windscreen? So one of the applications is to have a touch control. For example, in a windshield, typically you have a sun visor. When the sun is directly hitting your face and you want to have a protection, you bring down a sun visor. You could have a shading with a touch control. So you mix one of the technology coming from PDLC and then a touch control. Actually, you could have a virtual touch on the sunroof and bring down a sun visor as and when you require, and it's adjustable, so you could size your sun visor according to your need. Another one, you could embed a screen, and that would give you a large capability for navigation, camera feedback, etc. So instead of the Ola driver constantly struggling with his mobile to have this, imagine a windshield which has already an embedded screen and constantly delivering information about navigation, what time you will reach, and things like that. So this is one application where you could embed a screen and have either a camera feedback or a navigation feedback or both on the windscreen itself. We spoke already about the augmented reality HUD application. So you could see navigation aids directly in front of you without you taking off your eye from the road. So that is another one. So with these things, you could have a lot of functionality, and put together, we could call it a smart windshield. Going further, today, what are you seeing more and more? So there are more and more cameras. In order to support ADAS, there are more sensors. You have a light sensor, you have a rain sensor to activate your wipers automatically. All these things are today being fixed. The glass maker currently only gives a passive plastic component, and it is a car maker who is adding active components and sensors onto the windshield, and at the end you have a fairly bulky design in the middle of the windshield. Can we also embed cameras, light sensors, rain sensors, etc. onto the windshield? So those are possibilities. Again, prototypes are being developed, and these are interesting times where we could have multiple things embedded onto a windshield, which is also has touch control onto it. So this could be the future of a windshield, where you have lighting elements, you have touch control, you have sun visor, and you also have multiple sensors embedded into the windshield itself. If you are further interested, we have a video which can be seen from the YouTube. Typically in sessions like this, if I try to play a video, it normally doesn't work, so I'm not doing that. But there is a video available in the YouTube, and you could go and look for Sangoban TV, and you could see Driving Tomorrow, which is an interesting video showing you multiple applications of what can be done in future. Continuing with embedded technology, the other area could be we are in an increasingly connected world. So here again, you need for connectivity antennas, and today sometimes you have a large rod type of antenna jutting out of your car, which is aesthetically not nice and sometimes practically also has problems on a low roof height areas where it can hit the roof and all those things. Can we integrate an antenna into the windshield itself? So there are many kinds of antennas which are now being either printed or embedded into a windshield. It could be also a high-end application where we could look at 4G and 5G connectivity, which are critical, especially 5G connectivity is essential for an autonomous car, which has to real-time transmit and receive large amount of data. But it can also be a fairly low-end application on a commercial vehicle where it's difficult to insert an antenna and the costs are also limited. Can we have a simple AM/FM patch antenna on the windshield, which could allow the commercial vehicle or a three-wheeler user to have a AM or FM radio? So you could have antenna for multiple applications, starting from simple radio communication all the way up to 5G communication. So this is another area where a lot of connectivity can happen through glass. And as you know, metal sometimes has a lot of interference. So glass becomes a good medium to embed an antenna. Similarly, now in any highway, it's mandatory to have a FASTag, which is nothing but an RFID. Could we also look at embedding RFID or NFC solutions into the windshield, which can be used for one, asset tagging and asset identification, two, for making payments, and three, probably in an application like Ola or Uber, where the customer experience can be enhanced and safety concerns can be also taken care with an embedded NFC or a RFID chip, which ensures that the car which you have booked is the car which you are getting into. So it can address many topics simultaneously, from asset identification, toll payment, and to user experience and safety concerns. So multiple options exist by embedding antennas, RFIDs, and NFC chips into the windshield. So this is one direction where there are a lot of development happening, and multiple agencies and multiple people are working towards how these technologies can be used. It can be also a very simple thing like a service center where you want to track where the vehicle has reached, and you get an automated message that the washing has been completed and you can pick up your car after half an hour, so you don't go to the service center and wait and just to realize that oil change is still going on. So there are it's up to the car maker and probably the service center and probably for the asset people to imagine what kind of solutions and systems they want to build in, but technologies are kind of already existing in order to achieve these kind of applications. So depending on the application, you could potentially customize some of these embedded technologies and utilize it. So this is really an interesting area where multiple developments are happening. So I just wanted to give you a flavor of various developments happening mainly in the new areas of electronics, coming along with glazing and adding value to the customer experience. So till now, what you have is what you call as a passive glass, which was just acting as an envelope. But tomorrow you will have glass actively participating in the journey, providing you two-way communication, providing you feedback, providing you many other services, and really being a functional element, which is an integral part of the car. So exciting times ahead with electric and autonomous car coming our way. So we see that many more such developments will keep happening. So this was a short overview. I just wanted to keep it short and crisp so that we have some more time for question answers. In this last slide, you can also see what I spoke about earlier, the Saint-Gobain Security TV, where you can see some of the videos which are quite interesting on possibilities with automotive glazing. Thank you.
Thank you so much, sir, for such an informative presentation. We will share the questions with you through a separate mail.
Okay.
Okay. Thank you.
Thank you very much.
Now, I would like to introduce our second speaker of the session, Shri Harish Joshi. Shri Harish Joshi is currently working as Deputy Manager in Component Testing Lab at ICAT Center 1. He has completed his bachelor's degree in Mechanical Engineering from Guru Jambeshwar University of Science and Technology, Hisar, in 2008. He has worked extensively in the field of DVPV testing of auto components and certification of safety critical components like DVPV testing of auto components of fuel tanks, rear view mirrors, safety glass, wheel rims, door latch, door retention components, hydraulic brake hose, air brake hose, hydraulic brake fluid, flammability testing of interior material, testing of metals, plastic, and rubbers, etc. during his career with ICAT. He has been instrumental in setting up the coolant analysis and hydraulic and pneumatic hoses testing, environmental and helmets testing facilities at ICAT, and has proven a history of problem solving. He is actively involved in new facility development for mechanical component testing and has keen interest in new technology topics related to component development. He has a record of proactive delivery and commitment to meet deadlines. We welcome you, sir. I would now request Shri Harish Joshi to start with their presentation.
Good afternoon, everybody. Maximum of our speakers have already spoken on the new technology and the procedures on the safety glass. So I will be presenting the test facilities involved in the safety glass, and I think maximum of the our attendees are new. So first of all, I'll give the brief idea on the ICAT facilities, then I'll move ahead for the safety glass testing facilities. So I'll be starting the presentation on ICAT facilities. अभी फिर से sorry, there was some problem in the network, so I was unable to connect. So hope I can see everybody, and you can see my presentation also. So about ICAT, ICAT is a center, is a testing center under NATRIP, National Automotive Testing R&D Infrastructure Project, Government of India. So here ICAT provides the services related to the test, validation, design, and homologation. It was established in 2006, and the human resource capital as on date is 475 regular, and 96 are the casual employees. So we are located around 38 kilometers from Delhi, and we have two centers located in Manesar. One is at Center 1. It is about 8 acres of the land, and Center 2 is 46.6 acres, where we have the test tracks and EMC laboratory. So the vision is to become the world-class R&D center assisting the automotive industry in the field of certification, technology, and design. And the mission is to adopt the cutting-edge technology for the component vehicle development, and to follow the world-class practices in design, innovation, and technology services, to build the technical expertise with the OEMs by building the teamwork and the commitment, and to deliver the quality services for the total customer satisfaction, and to establish the global benchmark in the field of the automotive certification, testing, and R&D. So this is the organogram of ICAT. We are under Ministry of Heavy Industries and Public Enterprises, under which one project was taken. The name of the project is NATRIP. The total investment from the government side is 560 million US dollars, and out of which in ICAT the total investment is 192 million US dollars. So this is the authorization status of ICAT. We have the authorization from Ministry of Road Transport and Highways for type approval and COPs under rule number 126. Then we have the authorization from CPCB for emission norms and noise and type approval for COP of generator sets. Our test facilities are NABL approved and VCA approved. We are the secretariat for the fuel efficiency norms by for MORTH, and our test facilities are BIS recognized for the pneumatic tires, safety glasses, and the engines, agriculture sprayers, UPS system, IT products, etc. Our facility certification is IMS, and we have the facility recognition from Scientific and Industrial Research Organization. Our certification partners are KIAPI Korea, IDIADA, NRCS South Africa, the TUV Rhineland and TUV Sud, and SGS and Bureau Veritas. And we have the various MOUs for the overseas business, and one is the KIAPI Korea, and the second one is the Gulf Tikku Dubai for the automotive and non-automotive work. We offer the services, the type approval services as per the CMVR rules and the Center Pollution Control Board norms, and we offer services as per the IS standard, AIS, and the European norms. We offer the developmental testing, pre-certification test, durability validation, functional development, and the performance and emission optimization. And as per the specific request of the client, we can conduct the pre-certification test. We are the secretariat for the CAFE norms for four-wheeler. We conduct the BIS type testing for genset, CRS, UPS, and luminaries. And we certainly take the research and developmental projects from the OEM, and with the joint collaboration, we execute it. This is the workflow which we follow in ICAT. We have the online certification system where the client can directly approach ICAT through internet. They can they can apply the job through the internet. We have the single point contact person, like the certification business cell is there, and they take care of the complete certification under ICAT. The client can register the case online, and they can monitor the progress also. And the case certification, cost finalization, everything we can conduct through it. And we conduct the scheduling, and the report generation can be done through IOCS. These are the facilities located at Center 1. We have the vehicle test lab, where we do the emission testing of the vehicles, and we have the MACD also, mileage accumulation chassis dynamometer. The second test lab is the engine test lab, where we conduct the engine testing. We can perform the engine durability, torque, and power measurement, and use the laboratories for the certification as well as for the developmental execution. We have a fatigue test lab, where we can do the fatigue testing of the component as well as the complete vehicles. We have automotive, electrical, and electronics lab, and we have automotive transmission engine test cell, where we conduct the transmission tests. And in Center 1, we have a photometry lab for the light and light signaling devices. The component test lab, where we conduct the component, all safety critical related components testing, and other components of the vehicle can be tested. We have infotronics labs, CAD CAE lab, and the alternate fuel lab also in the Center 1. The facilities available at Center 2 are electromagnetic compatibility lab. We have the chambers for vehicle as well as for components. We have crash test facilities available at passive safety lab located at Center 2. We have NVH lab and the vehicle dynamics lab, vehicle evolution lab, test tracks, and the tire test lab is available at Center 2. These are the various seminars and the events which we conduct in ICAT. It's one of the big event which we conduct is New Gen Mobility Summit, and there are a few other events we have mentioned here. We try to cover all the segments of the automotive, like the tire industry and the powertrain technology, and on the lighting devices also. Now I will go to the components lab details. So in components, we do the type approval and certification as per the central motor vehicle rules. We offer the testing and type approval and COP of all mechanical as well as the electrical and the lighting parts. So in components, the safety glass are there, fuel tanks, seats, hydraulic brake hoses, door locks, hinges, safety belts. The wheel rims, rear view mirrors, washer tanks, brake fluids. There are so many components which we do the testing and we give the certification. And for developmental testing, we do the test for the instrument panels, seats, complete HVAC system, floor console, fuel tanks. The fire detection, spray suppression testing we also do. We have the test facilities for charge air coolers, oil coolers, radiators, the interior and exterior rubber parts, the weather strips and AC hose assemblies, resonators, engine coolant and brake fluid. These are the detail of the major projects executed by us. So we have done the BSR testing and vibration testing on the instrument panels and floor console with the electrodynamic vibration shakers and the multi-axis simulation table. And there are few projects which we have done for the clutch and the brake pedal testing, where we have done the test for buzz and rattle, the deceptive strength, fracture test, rigidity test, and low transmission efficiency. And for the related to the radiator and CAC testing, we have the complete test facility related to the internal corrosion test for the radiator assembly, and the pressure cycle test for the CAC. And we have the dynamic test facility for the fifth wheel coupling used in the trailers, and for which we can conduct the dynamic as well as the static test. There we have shown few major tests involved in the various parts. Like for the rear view mirrors, we can conduct. We have already conducted more than 57 tests related to the rear view mirror, where you can see there are major the environmental as well as the durability tests are there. And for the other segments, like for the roof liners test facilities, as per the specific OEM standard, also we can conduct some physical testing as well as for the environmental tests, like the tensile, flexure, impact, and the related to the environmental testing like heat aging, wet heat aging, and the flammability test also. And we have conducted the test on degassing tanks, like thermal cycling, vibration, resistance to the coolant, and heat aging, the pulsating pressure, shock test, pressure cycle, and burst test. These all are the tests which we have already conducted for the other components. Like we can conduct the test on the instrument panel and floor console assembly, where we have done the BSR testing, the vibration test, the vibration durability on the mast, and the glow box, air vent, and some environmental test we can conduct. On seats, we can conduct the various tests as per the seats regulation as well as for the developmental exercise. And on the weather strips and automotive ceilings, there are many tests which we can conduct related to the environmental as well as for the some durability testing, product level tests also, which we have already mentioned. More than 20 tests we have already conducted. On CAC and oil coolers, we can conduct the test. For the component level certification, for all type of the components, we can conduct the test under certification named safety glass, rear view mirror, tires, wheel rims, fuel tanks, door hinge latches, hydraulic brake hoses, windscreen washer systems. We have facility. Hydraulic brake fluid, seats, CNG, LPG components, speed limiting devices, and tow hook testing. Fifth wheel coupling testing, we can conduct landing gear testing, window frame testing, flammability testing, safety belt testing, and seats and their anchorage testing. For the vehicle level certification, we have the test facility for the ATD to test, like for the unauthorized use of the vehicle for ATD for the steering lock testing, and rear view installation test, then PHS test, pillion handhold test, the spray separation testing, bumper impact, SBET test, safety belt anchorage test, temporary tires, interior fitting, and window retention test we can conduct under the vehicle level certification. The major facilities which are under the component test lab are the wheel rim test facilities, where we have the complete test facility for the approval of the wheels used in two-wheeler, three-wheeler, four-wheeler, and heavy commercial vehicles, HCVs. The capacity of ICAT is we can go up to the 50 kN of the bending moment we can achieve with the cornering fatigue test, and the radial fatigue testing we can go up to 7.5 ton. We can conduct the test. This is the exclusive test for the plastic fuel tanks for certification purpose, the fire test facilities. We can conduct the fire test. And for the interior fitting and head restraint testing as per the applicable standards, IS standards and EC standards. So we can conduct the certification test. For seat test for the buses as per AIS 23, we do the test and the certifications. The safety belt test facilities as per IS 15140, we have the complete test facilities. Apart from this, the vibration test facilities which we conduct the test, we have the electrodynamic vibration shakers. Total 6 vibration shakers we have. They have shown here only 2. So one is the 110 capacity and the second one is the 6000 capacity, 600 capacity ED shaker. It can be coupled with the climatic chamber. For the charge air coolers, the high temperature cycle test complete test we can conduct, and our range is from ambient to 200 degrees centigrade, and the pressure we can maintain 0.1 bar to 5 bar. We can program the cycle. For charge air coolers, we have the thermal cycle test rig also, where the range is 200 degrees centigrade and the pressure range up to 3 bar. And the low to high temperature changeover within 1 minute we can change. For the oil coolers, we have the complete developmental related test facilities. The test medium which we can use is coolant plus DI water. The pressure limit is up to 3 bar, and the temperature conditions from ambient to 180 degrees centigrade. This type of for oil coolers we can use this test facilities. And the safety belt encouraged test facility, the force the measuring capacity up to 30 kN we can go, and we can perform the SBAT test within 1 second. This is the fire detection suppression test facility, FDS, as per the AIS 135. We have the tilt test platform test facility for the trucks and buses for the certification purpose. For the lateral rollover stability, we can conduct the test. For survival space and the cap pendulum, which is used again for the cabins of the trucks, the impactor mass is 1500 kg. We can go. For the environmental test facilities, we have the various testing chambers, like weatherometer, thermal cycle chambers. We have many thermal cycle chambers, the ovens, walking chambers, humidity chambers, salt spray chambers, ozone chamber. We have the complete facility to simulate the environmental conditions. And the other test facilities, like for the hydraulic brake hoses, we have the complete test facilities. And the side door strength test, demist and defrost testing facility, and the haze meter for the safety glasses. The upcoming test facilities under ICAT is helmet test facilities as per IS 4151, and we are going to install the new facilities for the butterfly valve and the combination lock, and for brake lining test also. And we are going to have the new facility for the synthetic blood test facility for penetration test as per ASTM F1670. Now I will go through the test facilities related to safety glass only. The applicable test standard for the safety glasses, one is the IS 2553 part 1, that is for the non-automotive sector, and the second one is the IS 2553 part 2, which is for the automotive. The accreditation status of safety glass is the authorization as per type equivalent COP by MORTH under CMBR rules. And our test facilities are NABL and BIS accredited, and the facility certification is under IMS. These are the total tests involved in IS 2553 part 1 2018, where the total tests are 8 tests are there, and out of which only 6 tests are mandatory and 2 are optional tests. And in the laminated safety glass, only 1 test is optional. These are like thickness tests, dimensional, light stability, boil, bake, fracture, defects in central area, resistance to human impact. These are all are the tests which are involved for the testing of architectural glass, which falls under 2553 part 1. The testing facilities involved in the toughened safety glass part 1, the thickness test, facility, and the dimensional and squareness test, like the basic measuring instruments which we use, digital micrometer and the height gauges and measuring tape. And for the fragmentation test, the test is involved for the toughened safety glass, where we use the center punch and the hammer, etc. And the spirometer is used for the flatness test. For resistance to shock test, there are the various type of the balls are used. So for that particular test, the 1 kg steel ball is used, where we drop it from the 1 meter and we check for any fragments on the toughened safety glass. And our range is we can go up to 12 meters. The 4-point bending test involved in the toughened safety glass, where we check the mechanical strength of the glass. The capacity ICAT range is up to 100 kN. For the laminated glass under part 1, total 11 tests are involved in the laminated, and the tests involved are the thickness test and the edge displacement test. Dimensional testing involved in laminated safety glass to check the dimensions like the length and the width of the glasses. And light stability test, for which we have the weatherometer, where we simulate the light, where we check the light stability, will be done with the visual light transmission. And this is basically the before and after results of the glass. And for the boil test, we can go up to the 120 degree centigrade, although the range of the test was up to 100 degree centigrade. For the bake test, we have the range up to 200 degree centigrade. We can conduct the testing. For the fracture and adhesion test, we can go up to the height of 12 meter. However, the test shall be conducted at 4.8 meters of the height, and to check the any fragments, any detach on the samples after dropping the steel ball. Then the humidity test, for the humidity test, our range up to the humidity, we can go up to 95% of the humidity, and our range of the chamber is 2.5 meter cube. The human impact test rig, we have the human impact test rig to conduct the human impact test test of the safety glasses. And the now the for the part 2 test, IS 2553 part 2. For the toughened safety glass, there are total 4 tests are there: the thickness test, light transmission test, fragmentation test, and a 227 gram ball test. And for the laminated safety glass, there are total 11 tests are there: thickness test, light transmission, resistance to abrasion, resistance to radiation, high temperature test, humidity, optical distortion, image separation, head form test, 2260 gram ball drop test, and 227 gram ball drop test. For this toughened safety glass, the thickness and the light transmission, which we do with the measuring is the digital micrometer and the goniphotometer, visual light transmission we conduct. For fragmentation, again the same facility we use to check the fragments. And for the 227 gram ball drop test. And for the laminated safety glass testing, the resistance to abrasion test, which we conduct with the haze meter and the Tabor abrasion, and for the resistance to radiation for the with the weatherometer. And high temperature test, our range is up to 200 degrees centigrade. We can go for this testing. For the humidity, although the test conditions are 50 degrees centigrade and 95% RH, but we can achieve up to 90%, 98% RH, and we can go up to 90 degrees centigrade for the temperature. For laminated, say for secondary image test facility to check the secondary image or any optical distortion involved in the glass, we can conduct the test. And for the head impact, to check the injury in the impact suppose there is a impact on the windscreen, so to check that, we have the head form test. And for the ball drop test, we can go up to the height of 12 meters, and we have different sizes of the balls as per the regulations. So we can conduct the test as per the customer specifications also, although the as per the standards, the heights are 4 meters and for 9 meters for the impact test. Thank you. Thank you. This is all from my side.
Thank you so much for your presentation, sir. We will now have an interesting poll. I would request all the attendees to give their feedback against these questions, which are: what future testing facility you would like ICAT to offer to benefit your organization? Options are bulletproof glass testing, PVB layer DT testing, smart glass testing, paranomic windshield testing, gorilla glass testing. Request all of you to give your vote because we are ending this poll in 2 minutes. We are ending this poll now. Can we have the results, please? So the maximum votes has been sent to smart glass testing, and the next most preferred testing is bulletproof glass testing. We will take up these two points internally with our management. I would now like to request Dr. Madhusudan Joshi to deliver the vote of thanks for today's seminar.
Hello.
Yes, sir.
Am I audible?
Yes, sir.
Okay, thank you very much and good afternoon to all of you. It's a privilege to propose the vote of thanks for the seminar on International Symposium on Safety Glass Testing Technology. On behalf of Organizing Committee of ISSGT and ICAT, I would like to express my special thanks to all the delegates who have joined us from different places. I'm sure that we have succeeded in our effort to provide good information on quality control orders, future technologies, and current as well as upcoming regulations in today's session. Furthermore, I would like to express my heartfelt gratitude to the chief guest for inaugural function of ISSGT 2021 and other panelists for the inaugural session for supporting the event and sparing out their valuable time in motivating us in organizing the symposium at such a large scale. I would also like to express my special thanks to the eminent speakers from BIS, from Asahi Safety Glass, from IIT, BHU, from St. Gobain Glasses for accepting our invitation for the webinar, and I hope this webinar has turned out to be an ideal platform for sharing your views and with all the gathered delegates. Special gesture and special thanks to the sponsors who have supported this event in this very tough time of COVID, where businesses have gone for a toss. I would also like to express my special thanks to the media partners for extending their support for making this event very successful. I hope that they will continue to support us for all our future endeavors as well. I would like to congratulate the organizing team here at ICAT who have worked tirelessly and turned this dream into a reality despite of challenging times of COVID pandemic. We hope to keep organizing such events in future and provide all the people here with more and more relevant information and knowledge which is shared through these events and which would be helpful in catering to the requirements to all the stakeholders and to motivate the young engineers working in the safety glass industry. I once again like to thank all of you for organizing such a good webinar, such a good subject. Thank you very much. Jai Hind.
Thank you so much for your kind words, sir. I would like to thank all the delegates and speakers who joined us today in this seminar. With this, I, Devyani, signing off. Thank you.
International Center for Automotive Technology, ICAT. The most populous democracy in the world, the Republic of India is a vast South Asian country with diverse terrain ranging from the Himalayan peaks to Indian Ocean coastline and a history dating back 5 millennia. A cultural melting pot, it is a pluralistic, multilingual and multi-ethnic society which became one of the fastest growing major economies post market-based economic reforms in 1991. A key contributor to this enviable position is the automotive industry, which accounts for 7.1% of the country's gross domestic product, GDP. Located at the northern hub of automotive industry in Manesar, Haryana, ICAT has emerged as a comprehensive technical partner to the automotive industry and renders valuable services such as homologation and certification, developmental projects and testing and automotive R&D projects. The state-of-the-art infrastructure at ICAT is pivotal in carrying out these functions and can be broadly classified into following areas of excellence. Powertrain Laboratory. Powertrain Lab offers services in the fields of vehicle and engine emission and performance test, along with calibration services. The labs are fully equipped to undertake the homologation test of both the engine and the vehicle as per latest Indian, European and other international regulations of automobiles. Apart from homologation, performance measurement of engine and vehicle, fuel consumption measurement and optimization, emission tests and optimization including EGR, engine mapping, exhaust temperature optimization and ECU calibration of vehicles. Engine Test Cell, ETC. There are 13 transient test cells ranging from 35 kilowatt to 880 kilowatt capacity. These engine test cells are capable of carrying out advanced tests such as performance, optimization, emissions measurements, EGR and SCR optimization, durability and validation for engines for various automotive and no automotive applications. Vehicle Test Cell, VTC. There are 6 emissions vehicle chassis dynamometers and 3 mileage chassis dynamometers capable of testing vehicles up to 5,000 kg GVW. Each test cell is equipped to test and check various emission parameters such as hydrocarbon, carbon monoxide, carbon dioxide, nitrogen oxides and particulates as per BS6 and Euro 6 norms and durability and validation. The lab is also equipped for an on-road emission performance. Vehicle Evaluation Lab, VEL. Vehicle Evaluation Lab undertakes key tests including coast down, brake performance, maximum speed, fuel consumption, acceleration and performance, drivability trials, tire noise testing, endurance and durability tests, ABS test, etc. as per the specific needs of the customer on test tracks. Component Certification Lab, CCL. Component Certification Lab CCL provides services related to certification and homologation of automotive components. As per Central Motor Vehicle Rules, CMVR, the lab undertakes developmental testing, environmental testing, vibration testing, hot and cold chamber, weatherometer, ozone chamber, salt spray chamber, walk-in chamber, etc. for all components for on-road and off-road vehicles. Photometry Lab. Photometry Lab at ICAT is the state-of-the-art facility and one of the finest in the world. Fundamental research is carried out on LED measurement methods, spectroradiometric measurements techniques, visibility and glare, headlamp aiming, conspicuity, telematics, etc. Not only does the lab cater to automotive lighting, but also provides testing and development services to non-automotive applications, which includes domestic lighting and aviation lighting. Materials Lab. Multiple facilities available here in Materials Lab include mechanical testing of rubbers and plastics, coolant test facility, chemical testing of polymers, flammability testing of upholstery, carpet materials as well as inner components, wiring harness for kits used in automotive 2, 3 and 4-wheelers, etc. Fatigue Lab. In order to ascertain the life of products, extensive tests are undertaken by OEMs and their vendors. These tests include durability and integrity assessment of vehicles, systems and subsystems under various driving and environmental conditions. Fatigue Lab in ICAT has state-of-the-art facility wherein you can bring in road to the lab evaluation, multi-axis simulation tables, X-posters and various actuators in various simulated environmental conditions make this possible. Electromagnetic Compatibility Lab, EMC. The application of electronics has significantly increased in automobiles over last few decades. In view of this, the electromagnetic compatibility compliance has become of paramount importance both at the device as well as vehicle level. Passive Safety Lab simulates various crash scenarios. This is to ensure occupant and pedestrian protection in the event when a vehicle encounters a crash and the ability of the vehicle structure to absorb the energy of the impact. Some of the services offered are frontal impact crash test, side impact crash test, side pole impact, rear impact test, static rollover, pedestrian protection testing, etc. A notable point is that ICAT was the first organization to set up pedestrian safety lab in India. Tire Test Lab. Tire, being crucial for the road safety, comfort and fuel economy of the vehicle, needs to undergo a comprehensive and rigorous testing to evaluate and ensure its adequate performance. Both performance and rolling resistance evaluation of tires for various category of vehicles is undertaken in this lab. Noise, Vibration and Harshness Lab. A Center of Excellence on Noise, Vibration and Harshness, NVH, is the first of its kind of facility in India to offer services for development of vehicles and components, testing and validation. The lab is equipped with the semi-anechoic chambers with chassis dynamometers and state-of-the-art equipment and instrumentation. Automotive Electronics and Electrical Lab. The AEEL at ICAT is one of the most important labs considering the rapid increase in the use of electrical and electronics in the vehicles. The major facilities available at AEEL are related to electrical measurements, ECU validation, environmental testing, altitude testing, dust and water ingress testing, thermal shock, vibration and shock testing, weather resistance, battery cyclers and motor test benches, etc. CAD-CAE Lab. CAD-CAE Lab helps in design and development of vehicle and its component. Here, components and vehicles are not only tested virtually, but also studied for modification and optimization if required. Apart from virtual testing, it offers other services such as CAD modeling, drawings, fixtures and structure design. ICAT is poised to develop into Automotive Development Center, not only to provide certification services, but also product development services to Indian and global OEMs. At ICAT, we constantly strive for excellence, both in terms of building facilities and building matching skills. International Center for Automotive Technology, ICAT.